Hello everyone. This video marks the beginning of a new course in which we will be creating a real-time video call application using Next.js, React, WebRTC for peer-to-peer communication, Socket.io for signaling, and we'll be making use of Clark for authentication. So in this video, I want to show you the demo of the application that we will be working on. And as you can see, I have three browser tabs open right here. Basically, what we will be doing is that we'll be able to log in as users and show the online users just right here. Right here I'm logged in, right here I'm logged in, but right here I am not logged in. And as you can see here, I can see the two users whom are logged in, and here you are seeing only one user, which is this one. We are not showing ourselves. And once I log in right here, we'll be able to add another user right here as an online user. Okay, another thing is that if I happen to close this tab, you'll notice that this user with this particular logo will no longer be online. So if I close it, you'll see that that will automatically be removed because we are no longer like online. Okay, and we'll be making use of Socket.io to detect online users. So I'll bring that back, and then I want to sign in right here, and we'll be making use of Clark to create this auth, and I can continue with one of my Google accounts. And once I am logged in here, you can see now I'm logged in here. You'll see that this user is added to the other browser tabs as an online user, just like that. So what we'll be doing is once we click a user right here, we'll be able to initiate a call to the other user, and they'll see a notification of an incoming call. So let's just do that. Actually, what I'll do, we'll no longer use this window here. I just wanted to show you about online users and so on. So I think I'll go ahead and close this one. I can click on this user and we'll initialize a call to this one. So I'll click. You'll notice that it will initialize a call, and we can see our own video right here. And then right here, we have an incoming call, which is a video call. And once I click answer, these using Socket.io, send a notification to this particular user, tell them that we have answered a call, and we'll be able to share the video data and the voice data using WebRTC. So I'll click on answer here. And as you can see, now we have answered. Now we have this top video right here is our video. This is for the other user right here, but we are saying the same thing because they're using the same camera here. And this is it. Like now we can communicate through video and through audio. Right now you can't hear the voice and so on because I have like turned off the voice. It will be so like noisy and so on. But yeah, this is it. Another thing is that we will be able to toggle the video here. As you can see, we have hidden our video here and we can't see it here. So we'll be able to toggle the video, and also we'll be able to toggle the audio just like that. Another thing, we can just end the call, and after call ended, for both of them, it's gone. Again, this one can initialize a call as well. So if I click here, we will initialize the call and we'll see an incoming call. We can answer and we'll be able to get the call again going. Another thing is that we'll be able to block these now. Like once we are already in a call, we'll be able to block that already another call, so we can't make a call. Or if another user is on a call, we'll not be able to call them because they are in a call. And this is basically it. It's a very simple application, but you'll get to learn a lot about WebRTC, Socket.io, and we'll also be doing this on Next.js and making use of React, of which I think there are not many videos showing this. They are using other means of signaling. They are not using Socket.io. They are using some third-party libraries or applications. And yeah, so we'll be doing all this from scratch, which is really cool. In case you need access to the source code will be available on my Patreon. All you need to do is to subscribe as a member, and this is one of the best ways that you can get support my content so that I continue creating free courses to you. once you subscribe as a member, you'll not only get access to the source code for this application, but also for all the other applications that I have done here on YouTube. You'll get access to big applications like the hotel booking web app, we have e-commerce web app, chat applications, and so much more, including portfolio and so on. I'll also always leave a link to the tutorial for a particular source code, and also a link to how you can go ahead and install the application. And yeah, all you need to do is to join as a member and enjoy the benefits. So I'll leave a link to the source code at the description section below. So I'll see you on the next one, where I will get started by creating a Next.js application. In this episode, we are going to create our Next.js application, and we will also work on authentication by making use of Clark. So to create the Next.js application, we just need to run this particular command, and you need to have Node.js version 18.17 or later installed. So once you have Node.js ready, all you need to do is to run this command. I'll go ahead and copy the command. And then I'll open a folder here. So I already have this empty folder. I'll go to the path and I'll type cmd, hit enter on Windows, and this will open the terminal on this particular path. Okay, and right here is where I'll run my command. So I'll paste it and hit enter. Then we give the name of the application. Since we are already on this folder, I just need to include a period or a full stop there and hit enter, and then this will take the name of this particular folder as the name of the project. Would you like to use TypeScript? I'll say yes. Would you like to use ESLint? Yes. Tailwind CSS? Yes. SLC directory? No, I'll go with the default. App router? Yes. Would you like to use the import alias? Yes. What import alias would you like to configure? I'll go with the default, and then this will go ahead and create a Next.js application for us. So as you can see, it's done now. Success, created vid chart at that path. Now we can open this with Visual Studio Code, or you open with your code editor. I'm using Visual Studio Code, and I'll say code space and a full stop, hit enter, and that will open the project on Visual Studio Code. And here we go, we have the project. We are making use of the app router to run the application. It's pretty easy. I'll use Ctrl J to pop the terminal here, and right here I can say npm run dev to run this application, and you can find that on package.json file. So script dev. So if you run npm run dev, it will run this command next dev. Our application will be ready on localhost 3000. So we can visit that app by control, then click that link, and it should open on the browser. It opened on the browser, and we can see that we are on localhost 3000. This is the default template that comes with Next.js. You can just come to app, then page. This is the default page, and this is everything that you are seeing here, all this. So all you can do is to highlight this main. So I'll click at the bottom, then shift click at the top, remove everything, and I can say div, and here I'll say vid chat. I save, and now everything here will be cleared. So as you can see, it's cleared. Also we have more styles like the dark theme and so on. So to remove all that, I'll first remove the import of the image. We can go to global.css here, and as you can see, we have some styles. And what I'll do, I'll remove everything, and I'll remain with these Tailwind directives. So I remove everything right here, and we remain with these Tailwind directives because we need them for making use of Tailwind CSS. So I save, and now the dark theme should be gone, and so on. And as you can see, we have our application empty. The beginning of our application is right here at our layout, and as you can see, we have our HTML here, the body, and then the children. The children will be the various pages, and the first page is this one right here, where we said vid chart. this is now like our home page. In this application, we won't need many pages, just this one and maybe 2 more pages for sign in and for register. But for now, we have these. The way we define the meta tags in Next.js is by exporting these metadata object. And then right here, you can see we have the title, the description, and so on. So what I'll do right here, I'll just remove the title and I'll say vid chat. And for the description, you can say video call. Then for font, this is how we get the font. We just import inter from Google here, call this inter as a method, and we pass some configuration. Then we get this inter object, which will have a class name. So we pass it like this, and then the app will make use of inter, just like that. So yeah, that's the basic of our app there. Now I want to go ahead and we immediately start working on authentication. Adding authentication with Clark is very easy. So you can go to clark.com docs, visit this link if you can see it, quick start / Next.js, and right here you'll see the instructions of how you can go about working with Clark. The first thing that we need to do is to install Clark / Next.js. I'll copy that command, and then at the terminal here we can add another terminal, and for this second terminal we can use it to install stuff. So right here I'll just paste the command and I'll hit enter. So this will install Clark in our application. The second step is to configure environment variables. So if I come to Clark dashboard, okay, first of all what you need to do is to create a Clark account. You can continue with a GitHub, I think, or Gmail. Once you create the account, then you'll go to dashboard and you can create an application. So right now I already have some application here, and I'll create another one, and I can call this one vid chat, and I'll add YT. Then you'll choose the things that you want to log in with. So we have email and Google, those are the defaults. So if you add more, you'll see how it will look like right here. For example, if I add GitHub, you see it adds GitHub, Apple, it add Apple, Facebook, it add Facebook. But for now, I just want these, just the two. So I'll go ahead and create the application. And then right here, you can select the library that you're using. Right now it's Next.js, the framework. And it gives us the same instructions that we saw at our quick guide here. And actually, I think we will follow this one because it will already give you the keys right here. You don't need to go and look for them. Right here, you'll need to go and look for them, but right here, they'll be pre-filled for you. So we will add these keys at our .env.local. So I copy that. Then I go to our application here. I add a file and I'll say .env.local, and right here I'll just paste those keys. Don't use mine because later on I'll delete my. We continue here. We need to create middleware.ts at the root of the application. Click out here and then add a file. So you'll just say middleware.ts, hit enter. Then right here you'll just copy this and you'll paste it here. Okay, go ahead and save. Then go down here. We need to add a Clark provider. We do this at our layout, which is the beginning of our application. We go to our app and then at layout.tsx, we will wrap our application with the Clark provider. Clark provider. This will come from at Clark Next.js. Then we'll have this crossing part of it, then we'll add it at the end here and I'll save. So what we have done, we have covered or we have wrapped our application with this Clark provider, just like they have done right here. So now once we wrap with Clark provider, what I'll do, I'll create the 2 pages for sign in and for sign up. At our application, I'll add a new folder and I'll use these brackets and I'll say Clark. This Clark will not show at our URL while we are trying to visit a page. It's just for grouping our authentication. And this method that I'm following here is actually on this extra part. Utilize your own pages for authentication. So if you continue here with the guide, this is what you'll be shown, I think. So as you can see here, you create a page called sign up, then you'll create a path like this, then the page itself, then you'll have your sign up page like this. So this is what I want to do. First of all, I am grouping those two pages, the sign up and the sign in, for authentication. So right here, I just add now sign up. Then I'll add another folder in sign up, and then I'll use this particular syntax where we have two square brackets, opening and closing, at the middle, 3 dots, then sign up, like that. Inside now this folder, we add page.tsx. Then we just copy this code right here and we'll paste it in here, just like that. So we'll do the same for sign in. So I'll add a new folder and I'll say sign-in, and then in there, let's come down here. This is the guide here. We'll add another folder inside sign in now, the square brackets, then 3 dots, then sign-in, hit enter, and we'll add our page.tsx. Then we copy this and we paste it here. And as you can see, we are getting this sign-in component from Crack.js, and this sign-in will basically give us the sign-in form. So I go ahead and save, and if you go to app, you should have Crack. Then when you open Crack, you have 2 levels, sign in and sign up. When you open sign in, you have these and then page. When you open sign up, you have these and then page. So that is like the structure there. Okay, then update your environment variables. So we'll just copy these and we'll paste them in our environment variables. So I'll copy that and I'll go to our env.local and we will update them right here, and I'll go ahead and save. So we have the sign in URL as sign in, the sign up URL as sign up. To visit those, you can come back to the application. If I refresh, nothing happens, but now you can amazingly go to sign in. When you hit enter, that loads our sign in page, and as you can see, we have this sign in form which you can actually continue with Google to sign in, or you can click sign up here and it will take you to the sign up page by itself, just like that. Very nice. So we just need to style this better so that this is at the center of the page. At our app, then Crack, I'll add a layout, and that layout will be shared by these two pages since they are under the same. So right here, I'll add a folder and I'll call it layout.tsx. In this layout, we will style everything to be at the center. I'll say const Crack layout will be equal to an arrow function. I will return a div, and here we will pass the children. Now these children will be the various pages that are under this Crack. So that will be this page and this page. These children complains because we should bring it in from props. So right here, I'll destructure it from props as children, and then I'll add the type for this. Remember, we are working with TypeScript. So right here, I'll add the type. Children will be of type React node. Now I can add the common styles right here. I'll add a class name. We will make use of Tailwind CSS, and we'll say height is screen. Then we will flex. Then we will say items will be at the center, and we will justify center. We'll just come right here and we'll say export default, and then we'll say Crack layout. By default, like Next.js will know about this particular layout. Okay, this structure that we have here, it will know that this layout will be the start of our page if we visit stroke sign up or stroke sign in. So as you can see now, this is at the center because we centered it right here using this div, and it's shared. So if we go to sign up, it's still at the center. So I want us to like wrap up everything about authentication. I'll create a navbar, and then at the navbar we can have somewhere where we can have sign in. Okay, easier for navigation. Right now we have to go right here at the path and switch manually. Now about our navbar, I made use of a few components from Chaoo UI. We won't use it in many parts of the application though, but this is a good chance for you to learn about Chaoo/UI. So right here, just search for Chaoo. You'll see Chaoo/UI. Let me expand this. I need to go to the docs or something, get started, installation, Next.js. Okay, first of all, it shows you how to install Next.js application. We have already created a Next.js application. Then it shows you how to add Chaoo/UI. So we copy this command now. So I copy that particular command. I go to our app and I paste it. I install. So I hit enter to add Chaoo in our application. We configure some defaults. Which style would you like to use? I'll go with the default. I'll hit enter. Then I'll go with straight as the base color. Would you like to use CSS variables? I'll say yes. And it will initialize some stuff for us. And as you can see, it added these components folder. Another thing that it added is this lib folder. And this lib folder have utils. And the utils, all it has is a cn function. So this cn function makes use of Tailwind merge, and it's very nice for merging various Tailwind classes. I think we might get to use it later on while working with Tailwind CSS. So we have added Chaoo. With Chaoo, we don't bring in all the components from Chaoo. We just bring in the components that we need, and that makes our application to be lightweight. The components are highly customizable, which makes Chaoo to be one of the popular libraries. So basically what I'll do, I'll go to components here and I can search. So search here and I'll say button. Let me show you how you add Chaoo components to your application. So you'll see here is the button. The button looks like this. Then to add it, you just install individual buttons or individual components. So right here, I'll run this command, copy, I'll paste it here and hit enter. And this will add the button component in this components folder. I'll hit enter and it's installing the button. And as you can see, we now have a UI, and then inside UI, we have the button. I'll wait for it to complete installing it. Once it's done and click on the button, you'll see this is our button. We have all the styles here. It's highly customizable. You can change stuff if you want and so on. So this is the good thing with the Chaoo UI library. Now let's go ahead and create our navbar. Inside the components, I'll add a new folder and I'll say layout. You can add different folders in this components folder, but this UI folder will be specifically be holding the Chaoo UI components. In this case, at layout is where I'll add our navbar. So I'll say navbar.tsx. I'll hit enter, and then right here SFC. This is an extension that I'm using. So SFC is short for stateless functional component. I'll hit enter. Okay, the extension is called Simple React Snippets, a VS Code extension. Then right here I can say navbar. I'll add a div. And for our navbar, we'll also be having a container. So we also need a container component, which I'll create right here. So I'll add a new one and I'll say container.tsx, stateless functional component, and I'll say container. It will receive children, and right here we can destructure children as props. Then right here we'll add the type for the children, and I'll say children will be of type react.react node, just like that. Then right here our container will return a div, and the div here will be having the children as the content. Then for the div, we'll add a class name and we'll set a max hyphen width of about 1920px. We will add width to be full, margin along the x-axis to be auto. Then we'll have XL for larger screens. Padding along the x-axis will be 20. Then for small screens it will be 4. And then padding along the y-axis for all screens will be 4. So this is px, not pz, px. So I'll go ahead and save that. So that is our container component. We'll make use of it at our navbar. So right here I'll have the container component. So container coming from our .container. This Lucid React was installed together with shardcn, so don't confuse. Bring it from this one, just like that, and that will wrap the contents of our navbar. Right here it complains because it expects some children. So if we happen to add a div, that error will disappear. Very nice. So this parent div here for our navbar, let's add some style, and I'll say it will be sticky, and top will be 0, and then we'll have a border, and we'll have border bottom color to be primary, then stroke 10 is like an opacity for it. So our navbar will have two parts. On the left we'll have the logo, and the other side we'll have the buttons for signing. Let's add a div. The div will also have two things. I'll add an icon called video, and this will come from Lucid React. And then right here we'll have a div, and then we'll say vid chat. I'll add a class name. Let font be bold, and let text be Excel. Then for this one we'll also have a class name. We'll say flex, then items will be center, then let's have a small gap of 1, and let's have cursor here as pointer. If we happen to click this logo which we are creating, we'll say on click, and we will direct the user to the home page. So here I'll say let this go to our router okay, we first define this router. Right here we define the router, and I'll say const router will be equal to use router, and this comes from Next.router. Actually not from Next.router, but from Next.navigation. So this is like the latest one. Now we can make use of this router here. We say router here dot push. We specify the path, which is the home page. So if we click the logo, it takes us to the home page. Then another thing is that once we make use of a hook like this is a hook, we mark this component as a client component. Remember in Next.js we have both server components and client components. So right here I'll say use client. And I think we can preview it so that we see the progress as we move on, and you know, so that you can fix any issues early. We need to hook our navbar at our app layout. At the top of the children is where I'll add the navbar, and before that I'll also define a main tag, and I'll pass children to be inside main. Then this main will be having some styles, so I'll add a class name, and I'll say flex will flex column, and then I'll say mean hyphen height will be screen, and bg let it be secondary. I save to auto format. Then in here at the top of the children is where I'll add the navbar component. So I'll say navbar, just like that. Then for these children I will wrap it with the container component which we created earlier. So I'll say container. Okay, it will be from components layout. Then we pass children there, and I save. Now once I save, since we have hooked our navbar here, I believe we should be able to see it here. Okay, there we go. Nice. So now as you can see, for our navbar we are able to see this section where we added the video icon coming from Lucid React. Then we had the vid chat as the name there. Now the next step is to add some buttons on the side there. So after this div, We hit enter, and right here we'll have another div. So I'll say div, and in this div we will show a component which will come from Clark. That is the user button component from Clark Next.js. Now another thing is that we can get a user from Clark right here. I'll say const, I'll destructure user ID. We can make use of use auth, and this use auth hook comes from Clark Next.js. So we invoke that and we can be able to destructure a user ID. This user ID will be important because it will help us know whether we are logged in or not. So after our user button, we can make use of that user ID. If we don't have the user ID, we'll go ahead and we'll show our buttons, our sign in and our sign out buttons. So right here, I'll have a button. The button will come from a UI button. So this is a shared CN button. And here we will say sign in. Then right here we might have the various props. Size will be small. Variant will be outline, like that. Then we'll be having a similar button for sign up. So here I'll say sign up, like that. The variant for sign up will be the default, which is not outlined. So I'll remove variant there. Now, if I save, we should already see some buttons here. Anywhere, I don't know where they'll show. Okay, they showed right here. So as you can see, we have two different buttons, one sign in, one sign up. To style this nicely, I'll come to this particular div. So I'll say class name, then we flex, gap of 3 between the buttons, then items will be at the center. I save. Yeah, there we go. We have a gap between them. And then we want this sign in and sign up to be on this side, this logo to be on this side. So we come to this parent div. This is the logo, this is the buttons. So we add some styles right here. So we'll add a class name and we'll flex, we'll justify between, and then we will say items to be center. I go ahead and save, and now these will be pushed. They should be pushed all the way. Yeah, there we go. So now look, it looks very, very neat. We have the logo here, the sign in and the sign up on the other side. Now the next thing, when we click sign in, it should take us to sign in. When we click sign up, it takes us to sign up. We have already defined a router, so we just need to add on-click events to these buttons. So I'll say on-click. Here we will run a function that will return router.push, and we invoke this, and here we'll say stroke sign in. Then we copy this one, copy, then paste. This one will take us to sign up. I save, and that is our navbar. To test out, let's click on sign in, and it goes to the sign in page. Click sign up, goes to the sign up page. As you can see, working with Clark is very easy. Just to work on some UI and everything is up. Continue with Google. So I'll log in with one of my Google account, and once I'm logged in, you'll notice that this will hide and then we'll show a user button. So I logged in with Google. I'll give it some time to process, and there we go. We are logged in. We no longer see sign in and sign up. We have a user ID, and we can actually see a user account here which you can manage. Very nice. So as you can see, we have done a lot of stuff in this just one video. We created the Next.js application. We have used shared CN for our buttons. We have added Clark authentication. We have created our navbar, and we have covered a lot already. So in the next episode, we will create a custom socket.io server on our Next.js application, and you'll see how we'll go about that one. So I'll see you on the next one. If you enjoyed the video, please make sure you subscribe, turn on post notification, and yeah, leave a thumbs up. In the last episode, we were able to work on authentication by making use of Clark. And in this episode, I want us to create our socket server. And we have a guide on socket.io. I'll leave a link at the description section below to it, but you can also type it out right here. You can follow this link. And basically, socket.io server can share the same underlying HTTP server with Next.js. And it is easy to create this server because we already have all the code that we need to get started. The first thing that we need to do is to create this server.js file at the root of the application. So I'll come at the root, I'll add a file, and I'll say server.js. And then I'll just copy this code, and I'll paste it here, and I'll try to explain what is going on. Now, one thing with creating the server this way is that you won't be able to deploy your application to Vercel as it does not support WebSocket connections. But don't worry, once we complete the application, I'll show you how we will deploy our application in a different platform for free. Once I copy this code, I come to my app here, and let's see what is going on. So basically, we will create a socket.io server that will share the same HTTP server with our Next.js application. And we are making use of three things to create this server. We are making use of Node, Next.js, and socket.io. So you need to have socket.io installed. Let's install it. I'll copy that one. Then I'll add a terminal. And once I add a terminal, I'll say npm i socket.io. I install it. So once we dive into the code, we will start at try 9. And basically what we are doing at try 9 is to create a Next.js application. We create the app, and then we come right here, we prepare the app, and once it's ready, we will be able to run this function in here. In this particular function, we are creating a HTTP server, and we are making use of Node.js. This create server comes from Node. So we create a HTTP server by making use of Node.js, but we are also passing it something else here. And this is the handler that is coming from our Next.js application. So basically, we are creating a HTTP server by making use of Node.js and our Next.js app. And then right here, we are able to create our socket.io server by making use of this HTTP server. We pass it to our server here, and this server is coming from socket.io. Now that we have this IO, which is our server, we will be able to listen to events from the client, like the connection event like this. And also we will be able to use it to fire events to the client. Now, how do we get to run our server and together with our application? So we need to change the scripts. I'll come right here and I'll go to package.json file. This is where we will have the different scripts for running our application. And as you can see right here, we were using dev, next dev. So we'll change this. What we will do, we will run this command now, node. Then right here, we will run our file, which is server.js. So this is the new way that we will be able to run our application. From the documentation, that is exactly what they recommend. You remove this, then you add this. Also here we remove start, next start, we add this start, we check if you are on production, and we run node server.js. So you can just copy that one and you replace it with this particular start. So one thing that we need to do is that this server.js, our server, is making use of this import statement, and this is the ES6 syntax. And if we try to run our application with Node server.js, you'll notice that it throws an error. Let's just do that and you'll see npm run dev. So once we do that, it will run this particular script and run our server.js. And for now, I think we should get an error because of the imports. So here we'll see syntax error, cannot use import statement outside a module. So we need to tell our application that it should use the import statement even on our server. And we will do that at our package.json file. So what we need to do, we just need to come here and we'll add a type. We will say type, and right here we'll say the type is module. Initially it was using CommonJS by default, and that's why it was complaining. So I save, And once I do that, now we should be able to run our application. So here I run npm run dev again and see what happens. And it's ready now on localhost 3000. Let's visit that link right here. It will load, it will compile our code, and I will give it some seconds for it to complete. As you can see now, our application still runs. And if we happen to log something to the console right here, so let's see if it gets logged, console.log, to make sure that this file is running. So let's say running, and we save. Now, one problem that we will face while working with this server is that it does not auto refresh. So it is not automatically running this server.js file whenever we make a change to it. Although when we make a change to the client will still auto reload because of Next.js, but this server, it's our Socket.io server, and it doesn't. So what we can do is to make use of nodemon. So what we can do is to stop the server and run this command npm I, then use -D, then say no daemon or nodemon, and hit enter. Nodemon. No daemon sounds crazy. And we can write our own script. So we can write our own script which we'll be using. You can still use this one, but let's write our own here. I'll duplicate it and I'll say nodemon. And right here I'll say we will now run nodemon and then server.js. So we'll run this particular command. So what we will do now is right here, instead of saying npm run dev, I can say npm run nodemon, and it will still run our application. So save this file, and then let's see if we see this particular console log by saying here npm run nodemon and hit enter. So let's see if our app still runs, and you can see our application is running, and you can see right here running. That is this particular console log. Now the good thing with nodemon is that it's listening to any changes. So right here, if I happen to add something and we save, it will detect the change and it will automatically rerun our server, and we still see running here with the change. So that is a good thing. And now our app is still running. If we refresh, we should see everything is still working. So very nice. So this is how you can create your Socket server. It's super easy. And the next thing that I want us to do is to listen to this connection on the client, and then we'll be able to log something to the console whenever someone connects. Okay, so I'll see you on the next one. Hello everyone. In the last episode, we were able to set up our Socket server, and in this particular episode, I want us to work on our client where we'll be able to set up online users. And then in the next episode, we'll be able to show those online users on our UI. And the first thing that we will do is to set up a Socket context at the root of the application. We will add a new folder and we'll call this one context. Right here, we'll add a new file and we'll say socket context.tsx. Then in here, we can set up a context. So we use context in React for global state, okay? We will export const socket context. We'll set this to be equal to create context, and this create context will come from React. I'll click this one that is from React and it will be auto imported. Then right here I will invoke, and we are supposed to have some default state. The default state in this case will just be null. So right here I'll say null, and we can define some types right here for this particular context. An interface which we'll define in a minute. So I'll say iSocket context, or it can be null. Let's define this iSocket context, I for interface. So here I'll just say interface and iSocket context. For now it can be empty, and then we'll be adding the types that we want to export from this particular context as we move on down here. we will export a provider, export const socket context provider, and we'll set this to be an arrow function. And what we will return here is a component which will come from our socket context here. So it will be like this, socket context dot provider. So this is the component that we will export. So this will expect us to have a value. The type for this value is the one that we will be defining right here. So by default, right now, it's just an object. We don't have anything. Now, at the bottom here, I'll export a hook, which will help us to read our context. And I'll say export const use socket. This is a custom hook now, will be equal to an arrow function that basically will return our context. So we need to read the context, and this is how we do it. We say const context will be equal to, we make use of a hook from React called use context, and we pass our socket context, this one right here. And once we do this, this context will basically have this particular value. We check if it has a value. So we'll say if context is null, we will throw an error here, and we'll say throw new error, like that. We invoke that. So if we try to make use of this use socket in a component that is not wrapped with this particular provider, this is the error that we will get. So right here, we go ahead and we return our context just like that. The next thing that we will do is to wrap our application with our socket provider. I'll come right here and I'll add a new folder at the root of the application, and I'll say provider or providers, and right here I'll add socket provider .tsx. We'll say use client. We'll create a stateless functional component, and we'll call this one socket provider. We will return socket context provider. It should come from our socket context. So control space, I import this from our socket context. We return this particular provider, which we defined right here, this one. And right here we'll pass children. These children will be able to get it right here as prop. So right here I'll say children. And right here I'll be able to define the type for this as React.React node. Now these complaints because we didn't accept any plop right here. So in this particular component, our socket context provider will be able to receive that children right here. And we can define the type as well of React.React node. I missed something at the front here, which is children full colon type React.React node. We receive the children, and then we wrap these children with this socket context dot provider. So right here I'll say children like that. I go ahead and save. The children will be the different components and pages in our application, which now will be able to access the values that we'll be able to define right here. So now to hook this up at our application, we need to go to our layout. So I'll go to layout, and we'll cover this main part right here with that particular socket provider. So right here I'll go ahead and say socket provider, and I can cover our main or wrap it with our socket provider. And once we do this, this main is the one that now will be passed as children right here. And every component that will be under this main, the navbar, the container, the children, which have the different pages, will now be able to access the values of our context. So now by doing this, we have already set up our context, and we can go ahead and start working on socket.io on our client side. The first thing that we will do is to initialize the socket on our client, and we'll make use of a library which is socket.io client. Add a terminal here and say npm I, and then you install socket.io-client, hit enter, and that will add socket.io for our client. And then in our socket context provider, just before our return statement, we can be able to define some states. So I'll say const socket, and then we will set socket. This will be equal to use state coming from React. We invoke that one, and it can be null. I can define the types, and I'll say the type for the socket will be socket. And this socket should come from our client side. Remember, we have this socket.io that is for our server, and then we have this socket.io client. So we use that one from client, or it can be null. So right here, what we are doing is initializing a socket, and then I'll say use effect. We pass an arrow function. It will have some dependency array as well. Now right here, I'll say const new socket will be equal to, we make use of a method called io, which will come from our socket client, and then we will invoke it. And just by doing that, we have initialized a socket. And since we are using the same HTTP server for our Next.js app on the client and that of socket.io, we don't need to pass any URL right here. So right here, we set our socket to be our new socket. In case this use effect runs again, we will be running a cleanup function so that we don't have many instances of our socket by returning this arrow function, and we'll say new socket dot disconnect. Whenever a user changes is when we will be able to run this use effect again, and we can get the user from our Clark auth. So right here I can say const user will be equal to use user, and this will come from Clark Next.js. That is a hook. Whenever this user changes, we'll be able to initialize a socket. Okay, we need to listen for connections and disconnections. I'll say const is connected, or you can say is socket connected. Set is socket connected to be equal to use state. By default, the value here will be false. We can now listen for connections and set up this is connected to true if we are connected. So right here, I'll make use of another use effect. We invoke it, we pass an arrow function, and at the end here, I'll have some dependency array. This use effect will run again when socket status changes. Okay, and then right here, I'll just first check if we have a socket. So do we have a socket? If socket is null, we will just return. We'll say if socket, our socket will have a property called connected. If socket is connected, you see we have connected and disconnected. If socket is connected, we will run a method here or a function which we will define called onConnect. And this onConnect will basically update our is socket connected status there. So onConnect, I invoke it. Okay, I will go ahead and I'll define this onConnect function onConnect. Right here, I'll just say set is socket connected to true, like that. And then I'll also have another function which is on disconnect. On disconnect, I'll invoke that one, and here I'll set is socket connected to false. So if we are already connected, we'll directly call this particular function right here. But right here, I'll listen to some events. So whenever we connect to our server or disconnect, our socket.io will automatically emit those events, the connect and disconnect events, and then we can listen to those events here on the client. So I listen to the connect event socket.on, and we listen to the connect event So once we connect, we will run the onConnect function right here, and then we will also resend to socket.disconnect event. So on disconnect, and here we will basically run the on disconnect function which we defined right there. So that way, this is socket connected will always tell us when we are connected to the socket or when we are disconnected to the socket. Here we have resent to these events, but then I will return a cleanup function. So I will return right here at the very bottom, and I will return this particular arrow function, and in here I will disconnect from these particular events. So right here I'll say socket.off, and I'll say connect, and then I'll say on connect. I just stop listening to those particular events, and then I'll say socket.off disconnect, and right here on disconnect. So basically, whenever we run this particular use effect again, when socket changes, these will first clean up the events, and then we will resend to those events again. So that is basically what is happening. And we can log this to the console and see if it works. So once we connect our browser, we should see is socket connected as true. So console.log of is socket or is connected, just to make it shorter, and I'll say here is socket connected, and I'll go ahead and save that one. And also we can do this on our server. So at server.js, whenever we connect, this is where the code will run. So on the server, I can say console.log, and I'll say client connected. So when our client connects, the server will resend to this particular event, and it will be able to run this callback function here. Also, I'll remove this running from there, and I'll save. Our server is running, and right now you can see we don't have this console log client connected, but let's come to the client and we hit a refresh. So we can see this client connected is there, but our client is connected is false. So something is wrong, and this also is running over and over and over again. Our app is going crazy. We have many renders, and that is because of this particular use effect. This user keeps on changing, and therefore we get so many renders. This effect is on a continuous loop. I made a mess in this particular user. I should have destructured it from our use user. So include these curly brackets like that, and that should prevent this user from changing many times. Now here we'll be able to get our user which doesn't keep on changing, and therefore our app will run more smoothly. So what I'll do, I will refresh the client, and then we see what happens. First of all, we get our console log here, client connected, like this, client connected, and then when it actually connect, it will update the state which is connected, and it will become true. We still have some re-renders, but at least it's not like continuous. And since we have events which will be changing the socket, the user, note that whenever you do a console log, you might face several re-renders. So when you see these, don't worry about it. Some people I see, they freak out when they see many console logs, which is totally normal with React because of the re-renders. Okay, so what I'll do now, I can just remove this console log, and we can be able to set up online users now that our client is being connected to our server. And this is not like things that I have come up with. Some of this is actually on the Socket.io documentation. So if you feel lost, you can just go to Socket.io, then you check for Next docs, how to use with Next.js. The docs that we were still going through in the last episode, I'll still leave a link to it at the description section below. So if you scroll down, you'll see that we have a client guide on how you can connect your client, and you'll see some of these is from there, like this particular use effect. You can see we are listening to the connect event, the disconnect. We are running on connect and on disconnect, which are these particular functions. And then whenever we are connected, we are running on connect. So kind of similar thing, okay? But now from there, there is no more guide on Socket.io, so we'll continue from there. And I want us to set up the online users. First of all, I think we can start on the server. So I'll come to the server here, and after our IO here, I'll set up a variable and I'll say let online users be equal to an empty array. And then right here, whenever we have a connection, we will have this callback function with a socket, and we can make use of this socket to listen to events. So right here, I will listen to an event that will come from client. I'll say add user, and right here I'll say socket.on. I'll invoke that, listen to an event called add new user. So we will fire this event from the client and we listen it here on our socket server. So if we get this particular event, we'll be able to get back a clerk user. So we'll get a clerk user from our client, and then right here we'll be able to do some stuff and add that user to these particular online users. First of all, we can check, does this clerk user exist at our online users? And if the user does not exist, we will basically add the user. So I'll say, do we have clerk user to begin with? And if we have, we check if this user exists. So we'll say online users dot sum. Here we'll get a user at a time, and then we return here. We check if this user that we get, dot user ID, is the same as this clerk user. So we'll say it's the same as clerk user dot ID. That means that that user already exists, okay? But we want the case where the user does not exist. So here, just include an exclamation mark. So basically, if we have a clerk user and this clerk user does not exist on our online users, we will go ahead here. So I'll say end and add that clerk user to our online users. So right here, I'll say online users dot push. I invoke that and I pass the online user that we want to push, which is our clerk user. First of all, I'll say the user ID here is our clerk user dot ID. I'll use a comma. I'll set up the socket ID for this particular user, and we'll say socket dot ID. So this socket ID is very important because we can fire events to a specific user. For example, whenever we initialize a call, whenever we call a user, we'll use that socket ID to only make a notification to them only, not everyone, okay? So these socket IDs are pretty important. Let's spell everything right here. Socket, and then here ID to be socket ID. And then right here, I'll include every other details about the user, because we might need to show the profile, username or profile picture and so on. So here I'll say profile is our clerk user, just like that. Once we add them at the end here, still inside our socket.on, at the end here, once we add them, we can emit an event that we have added an online user. So we emit to everyone who is online that we have a new user, so that they'll show on the UI. So right here I'll say io.emit. So we use the io on our server to emit events. So I'll say io.emit, and we'll say get users. So we emit this particular event and we will emit our online users. So we emit those users to our client. Now on our client, we will be able to listen to these get users, and we get our online users from the server. Very nice. I hope it's not confusing. Now this is adding a user whenever we connect. Now there are cases where we will disconnect, okay? So we need to remove a user whenever we disconnect. So still in our io.on, after our socket.on, we'll come right here and we'll say socket.on, and we will listen to the disconnect event. So whenever a client disconnect or a user disconnect, we will be able to remove those users from our online users. So right here, disconnect, and we'll do it like that. We return an arrow function. In this particular arrow function, we will filter out our online users. Right here, I'll say online users will be equal to, remember we had defined this as a variable using let, will be equal to, so we are updating it, online users dot filter. Then we invoke this one. We will get a user at a time, and we will be able to return those users whom user dot socket ID is not equal to our socket dot ID. So we make use of the socket ID to remove the user who disconnected from our online users, and then we emit back get users again. So right here, I'll copy this and I'll paste there. So if we disconnect, this will automatically update the client that we have updated our online users, and we get the new list of the online users. So here we are sending the active users, send active users, and that is our comment there. Again, here we are only sending the active users, just like that. Okay, very nice. Now let's work on the client and see how this will work out. We go to our socket context. In our socket context, we will start by setting up some state right here, and we'll say const online users, and we will set online users to be equal to use state. We invoke that. By default, it will be null. We will say the type will be socket user, and that will be an array of socket user, or it will be null. We need to define this particular type. So we can create a folder for the different types. So right here, I'll add a new folder and I'll say types. And right here, I'll add a new file and I can say index.ts. I'll export a type. So export type socket user, which will be equal to, our socket user have a user ID, which is a string. Then we have a socket ID, which is also a string. Then we have a profile. The profile will be of type user. User will come from our Clark Next.js, so user type. So we define that type socket user. We come back to our socket context and we import that socket user right here. So that will be the type of our online users. Now we come down here after this use effect. I'll define another use effect. In this particular use effect, we will set online users. Use effect, we pass an arrow function, expects us to have a dependency array. The dependencies here will be when socket changes, when is socket connected changes, and when user changes. We will be able to run this particular use effect. So right here, we'll first check if we don't have a socket, or if we are not connected, is connected. Okay, is socket connected? We will return. And then right here, we can emit an event to add a user. So we'll say socket.emit, and we will invoke that. The event that we will emit is the one that we listen to right here, add user. So we emit the event on the client, then we will resend it right here. So we emit the event add new user. Then right here, we will just pass our user. Once we do this, this user will be received right here as our Clark user, and then we'll be able to add that Clark user to the list of our online users. And then once we add from the server, we will emit get users. So once we emit get users on the server, we will pass the online users together with that event, and we can listen to these get users on the client. So on our client, here we have emitted add users, but now here we will listen to get users. So I'll say socket.on, we listen to get users. This event is the one that is fired by the server, and right here we will get back a response. This response is the online users, and here what I want to do is to run an arrow function, and we will be able to set our online users to be this response, and that response again is our online users that we get from our server. Now right here we will run a cleanup function. So I'll say return, and right here I will run an arrow function, and we will clean up the listening of this particular event. So for a meeting, we are not cleaning that one up. Where we are listening is the one that we are cleaning it up. So right here I'll say socket.off. Whenever we run this use effect again, before we run this cleanup function is the one that we run first to clean up the previous listening of events. And here what we will clean up is get users. Basically we will clean up this, so I can copy that and I'll paste it right here, and I'll save. And as you can see, it's pretty easy. We emit the event to our server listens to the event, gets the user, and add that user to our online users. Then it emits this particular event, and we will be able to listen to get users on our client, and we set that to our state. Then whenever we disconnect, our server will automatically detect that we have disconnected, so it will automatically detect a disconnect, and then we will filter out the user using the socket ID. The socket that have disconnected, we will remove that user from our online users, and then we'll emit the new list of online users to the other users. Okay, so we are emitting to everyone. Whenever we get to a situation where we emit to a specific person, you'll see how we do that. But for now, we are doing that for everyone. Now, this should work, and if we have issues, we'll fix them. But if we try to console log online users, we should get something. So console.log of online users, and right here I'll say online users. So let's see what we get, and I save. Now I come to our client. Our client is the browser, and let's refresh this page and see if we get anything. So sometimes our Clark user delays to show. Our online users are null, so something is wrong. Okay, actually I see here I'm emitting add new users. It should be add new user, because that is what we are listening to here, add new user. So that S might be messing things up, and let's try this again. I don't know if it resolves the issue, but let's see. I will refresh, and I'll inspect here, and as you can see, it starts off as null, but once the event is emitted and then we get back the get users, we are able to see that we have a user added here. Okay, again, don't worry about the many console log, especially because we are working with events here. The socket, the status of online users, all that will keep changing. That's why we see many console log. This is cool. We have added one user. Maybe we can try to log into our application using another account and see if we will be able to add this user. So what we can do, I'll copy this link and I'll open a private tab or another browser. You can use another browser or open a different private tab, and you run the app there. So here I am on a different browser, and yeah, now let's sign in here. This is a new user trying to sign in. So here I logged in with another profile. I signed up for another profile and logged in. And now as you can see, this automatically added that user as an online user on this other one. And you can see now we have two online users, which is pretty nice. They have different socket ID and different IDs. And also for this one, we should now be able to also see that we have two online users. So if I console log here, you'll see here we have two online users as well, this one and this one. So this is working very nice, and this is what we can do to set up our online users using Socket.io. And now in the next episode, we'll just take those online users and we'll be able to show them on the UI. So I'll see you on the next one. So in the last episode, we were able to set up our online users and we were able to log them at the console on the client. And in this episode, I just want us to take these online users and we'll show them on our UI. So the first thing that I'll do, I'll go at the top here where we had an interface called iSocket context, and we will add the type for online users. Online users will be of type socket user. This will be an array, can also be null. Once we do this, our value right here will expect us to add that particular online users. So inside this particular object, we'll say online users. Now these online users, it's this one right here from our state. So now all we can do is to go ahead and make use of this useSocket, and we'll be able to access these online users from any other component. I'll just go to the components and I'll add a new file. I can just add it at the root of our components, and I'll say list online users.tsx status functional component list online users. Right here we will return a div, and the good thing now is that we can be able to access our online users by doing this const with this structure online users from use socket, the custom hook that we defined, and we initialize that. We get our online users there. Another thing, we can get the current user by saying const with the structure user from use user coming from crack Next.js, and we can say that this particular component is a client component by adding the use client directive. Go ahead and save. I'll use these curly brackets and I'll say, do we have online users? If we do, we go ahead and say online users dot map. Here we will get an online user at a time, and we will be able to return something. Now here I'll use curly brackets so that we perform a check there, and then we will return here, and let's return a div. This div is not being suggested. Okay, we return a div like that. This div will need to have a key, and we'll set the key as our online user dot user ID. I can start by just showing the name, so I'll have another div. To get the name, I can say dot profile. Remember, we have a profile, then dot full name, then dot split, and I'll get the very first name by splitting using space. So here use these quotes and add a space, so we split the name using the space like that, and we get the first name, so like this. And I'll save this component and I'll go to app, then page, and right here instead of vid chart, I'll just include that particular component, which is list online users, just like that. I save and see if we get a user here, which should be this user currently. So we get one user, which is this user. We can see ourselves in this case, but as you can see, we are able to get an online user. I want us to style this and show an avatar and so on. Come to components, I'll add a new file and I'll say avatar.tsx status functional component, and I'll say avatar. this avatar will receive an image SRC, and right here it will return an image component from next image. This image component will be able to pass several stuffs: the SRC, which is SRC, an alt, and I'll say avatar, and we'll be able to have a class name, and I'll say rounded hyphen full. Then right here I have a height for it of 40. I'll have a width for it of 40, just like that. So it's a round image. So these complaints, because we don't know this particular type, but we can add it here. So I'll use a full colon and then a bracket, and I'll say SRC can be an optional string. Then we will be able to return this particular image if SRC exists. So right here, I'll perform a check. If we have SRC, that is when we will return this particular image component. If we don't have SRC, otherwise I will return a default avatar. So I will return an icon from React Icons, and I don't think we have installed React Icons before. So I'll just add another terminal, and I'll say npm I react hyphen icons. Then here we will return an icon from React Icons called far user circle. It's a font awesome icon from React Icons. So this means font awesome. We can now say far user circle. That will be the default if we don't have an image by default. So here say size is 24, and that is an avatar component which we can use at our list online users component. And before the name right here, it's where I have the avatar, just like that, and it expects us to pass the SRC. So right here say SRC, and I get the image, our online user, then dot profile, then dot image URL. Then we import this component and I save. So right here we get an error. Once I refresh, we get an error, and that is because we haven't added these in next config.js. So what we need to do is to go to next config, and there is a new way of adding the domain from where the image is coming from. I can't actually remember that right now, so I'll just use what I can remember, although it will give you a warning that this is deprecated. So at next config, I'll add this object, and I'll add images, then domains, and I'll add this particular domain. The image is coming from that. So I refresh there, and let's see if it works. So once our user loads, we get these like this. We have the name and the avatar. So we are already showing the online user. We just need to add some styles. For example, right here at the name, I'll say class name, and I'll say text is small. Then at the parent div that have the avatar and the name, we'll actually position these at the center. Right now you can't notice because the name is short, but it's not at the center in actual sense. So right here I'll just say flex. Okay, a class name first and then flex. Then we'll flex column, and then I'll say items to be center, and I'll add a gap of 1, and cursor will be pointer. I save, and now these will be perfectly at the center. Okay, it came right here. Now I'll come to the parent div that have these online users right here, and I'll add a class name, and I'll say flex gap of 4, and I'll add a border to the bottom, primary stroke 10. Actually I don't need the gap here, so I'll remove the gap. I'll say width full, and items to be at the center, then padding at the bottom to be 2. Okay, what am I missing here? Border hyphen bottom, and then we specify the color. So I save again, and there we go, we have this now online, and here we'll be able to list the different online users. So we just perform a check here. If our online user right here .profile.id is the same as the user.id there, we return null. That means that if it's ourselves, we return nothing, else we return that particular user. And by doing this, if we don't have any online user, we remain with this line. You can perform further checks at the top here if you don't want to see that line, but I'll just let it be. So I'll go ahead and save, and right now we can be able to detect online users and show them on the UI. I think I can test this by opening another browser and logging in as a user. So here I'll say localhost, and as you can see, once we go to this browser, we are automatically logged in, and right here this user was automatically added, and we have the user right here. Now I logged with an email and a password for this particular user, and that is why we don't see the name for this user. So this is working, and I'll see you on the next one, where we will handle clicking this user, and once we click, we will initiate a call to this particular user, so they'll be able to see a notification right here that someone is calling. In the last episode, we were able to list the different online users on our UI, and in this episode, I want us to create a function which, when we click a user profile, we will be able to initiate a call to the other user, and the other user will be able to see a notification of an incoming call. We'll still work with socket.io only, because we'll just emit an event to the server, then the server will emit a call, a notification event to the person who we are calling, and they'll be able to see that notification on their UI. What we'll do, we'll go to our socket context, and we will start right here by setting a state. The state will be called ongoing call. So right here I'll say const ongoing call, and we will set ongoing call, and then right here I'll say use state, and we'll define the type for that particular ongoing call, and by default these will be null. So the state right here can be null, but we'll also define a type. We had created a types folder, and I'll go to index.js, and right here I'll add that type. I will export type ongoing call. This will be equal to this object. We'll have the participants. The participants will be of type participants. We don't have this type, so let's define it. I'll copy this one, and then I'll export type participants will be equal to, we will have two things, the caller, the person who is initiating the call initially. So these will be of type socket user, the socket user we have here. Then we'll also have the receiver. So these will be also socket user. Now right here, I'll go ahead and say is ringing. So for an ongoing call, we'll have this particular property to see whether someone is currently calling us or not, okay? And I'll save. Then I'll just come right here and we'll add the type right here. We'll say ongoing call or null. We should import this ongoing call from our types. So control space, if you click at the end here and you hit control space, then it will give you a suggestion of the import, and you import that from the types. The next thing is to create a function. So maybe before our use effects, I'll keep those functions at the top here, and here maybe I can just remove this console log, and I'll say const handle call will be equal to, I'll make use of the use callback hook to optimize this function so that it doesn't run on every re-render, and therefore we return an arrow function in here, and this will have some dependency array. So handle, to spell it correctly. Now let's pass socket here, then current socket user. So this is the currently logged in user. I'll call the person current socket user, and now here I'll say ongoing call. We don't have this right now, but we should get that particular person from our online users. We are not using this user directory. We will use this user from online users because these online users have extra properties like the socket ID, which will be important for emitting the events and so on. Const current socket user will be equal to online users dot find, and right here we'll get an online user at a time, and then I'll be able to return online user dot user ID is equal to user dot ID. User ID here, this is like that, and then here I'll say const participants will be equal to the caller, and the caller in this case is the current socket user, so current socket user, and we'll have the receiver, and the receiver in this case is the person whom we are calling. We will set this to be user, and this user will get that through our function here. When we call this function, we'll pass the user along with that. So here I'll say user, and I'll say full colon, the user is of type socket user. So we get the participants like that. Then down here, I'll just go ahead and I'll set an ongoing call, set ongoing call, and we invoke that. We pass the different stuff for ongoing call, that is the participants, comma, and is ringing property. In this case, is ringing will be false. We are the person who are initiating the call, therefore we set is ringing to false. The participants, I think the spelling here is wrong, so I replace that. We still have an issue. I think the types should be the one that is having a problem. Yeah, the spelling here. So participants, come back. Okay, I should make sure that I have these current socket user. So right here I'll say if we don't have current socket user, we will go ahead and return immediately. Okay, and that is now fine. We get the participants like this, and we set our ongoing call like this. Then right here we will emit now an event. We'll say socket dot emit, and right here we will emit the call event, and right here I'll say participants like that. Sometimes socket might be null as well, so I think here you can say if current socket user is not available, or if we don't have a socket, we return. Then here we can just say socket.emit without that question mark. I hope that makes sense. So this is our function for emitting the call event. This function, we will call it whenever we click the user profile on our list of online users. Therefore, in components, then list online users. So here is where we'll have the on-click event, but we need to get that from our use socket. So let's come back here. We will add a type at iSocket context handle call, full colon. Then we'll have a user, and the user here will be of socket user. So this function will get the user. It will return void. So return void. Then down here now we can be able to add that at our value. So comma, and I'll say handle call. I save, I go to the list of online users, and we'll now be able to get that function from our use socket hook. So I can say handle call, and we get the function. We come right here at our div. Maybe after the key, I can say on click, an arrow function in here, which will return the handle call, and we invoke that one, and we pass the online user, this particular online user. Once we do that, we'll get this online user in our handle call. So back to this function, we get that user as user, and then those will be the receiver, and our current logged in user is the one that will be the caller. We can now resend to this particular event on our server. So I minimize everything and I go to the server.js. Maybe after the disconnect, I can come down there and I'll say call events, and we'll have different events here about the call. So here I'll say socket.on, and we will resend to the call event, and then right here on call we run this particular function. So right here I'll add a new folder and I'll say socket events. In socket events I'll add a new file and I'll say oncall.js. If you come to server.js, you'll notice that right here we had this const io new server, and this is the one that we are using to emit the different events. io emit. So I will export this io so that we can use it in other functions outside this file. So here I'll just say io is equals to that. Then outside our prepare here is where I'll define the io, and I'll say export let io. So we export io like that, but right here is where we assign it a value, so it will just update this. On our on call we'll be able to bring in that io, import id structure io, and right here these will come from server.js. We'll say const on call an async function which will receive the participants like that, and then we'll set this to be an arrow function, and we can do stuff in here. And then down here I can export default on call. If I go to server.js, so we need to import it from our socket events. So on call is coming from our socket events on call. Now, one thing with working on our server and with JavaScript, we have to specify right here that this is .js. Otherwise, it will not work. When we resend to this particular event, we will get to call this on call the participants to it automatically to it. On our on call we get those participants and we can do something with them. Now here we'll just perform a check. If we have our participants dot receiver dot socket id, then we'll go ahead and emit another event, and I'll say io.to. We will specify the socket id of the person that we are emitting to, and that is the receiver socket id. So here I'll just copy that and we emit to the receiver socket id, and then right here I'll say dot emit, and here we include whatever we are emitting. Here I'll say that the event will be incoming call. This is the event that we will listen to on the client, and we will pass the participants together with it. So participants. Now on our socket context, we will need to listen to the incoming call event. I'll go to our socket context and then I'll go to the very bottom after this particular use effect, I think so. Yeah, after this is the last one here. So I'll just add another use effect, and this use effect will listen to the calls events. Okay, so here we'll say use effect, and we'll have a dependency array. Here we'll have socket, is socket connected, and then we'll have the user on. Okay, and then now in here is where we will listen to the event. First of all, let's perform a check. If we don't have a socket, or if socket is not connected, then we will just return. If that passes, we'll go ahead and add the socket dot on, and we will listen to the incoming call event. And then right here we will run a function, and we can call it on incoming call. This function is not defined, so we will define it at the top, but we should also include this at our dependency array here. So here also include on incoming call. If that changes, we can run this use effect again. Now let's work on this particular function. I'll define the function just above our use effects, maybe after handle call. Const on incoming call will be equal to use callback. Then we invoke that. We will get the participants of type participants from our types. So I use these, and these will have dependency array. The dependency array will be the socket the user and the ongoing call. In here, we will be able to set ongoing call the participants, and then right here we'll set now is ringing to true, like we are receiving this call right here. Okay, very nice. Later on we'll come back to this on incoming call, and the idea is if we are already in a call, we will automatically hang up another user who is trying to call us because we have an ongoing call. And now we can be able to show a call notification on the UI by making use of this particular flag. I want to come back to this use effect. Let me save to auto format, and we will clean up listening of this event. I will return a function. I'll use these curly brackets and I'll say socket.off, and then right here I'll say on incoming call. So I go ahead and save, and now what I'll do, I'll go to our components, I'll add a new file, and I will say call notification .tsx, stateless functional component call notification, and then right here we will be able to return a div const with the structure ongoing call, and we'll get these from our use socket, and we invoke that one. Okay, we didn't export this ongoing call, therefore we get an error. We'll need to go back to our socket context, and from our socket context go at the very top and add a type here. You will say ongoing call full colon, and this will be of type ongoing call, or it can be null. We now add this to our value right here, so I'll just say ongoing call and then a comma. Now our call notification will be able to get this without an error. We'll make use of the property is ringing from our ongoing call to know whether a person is ringing or not. And right here what I'll do, I'll just say if we don't have ongoing call dot is ringing, then we will just return, we will not show the notification, else we will return this div. And what I'll do, I'll display this as absolute, so I'll say class name and I'll say absolute here, and this will be absolute to the body of our application. The body is at our layout, then we had body here. Here we had a class name of inter. Initially when we were starting this course, we installed shardcn. Shardcn came together with a function called cn function at our lib. We'll make use of this cn function to merge our tailwind classes. Back to app, then layout at our body. I'll say cn and then I'll invoke that. Okay, cn, I'll invoke that, and then I wrap like that. We import this cn from our lib. So from lib utils, use a comma here, and then I'll say relative, and that will merge those two classes. And then now in our call notification, this will be absolute to our body since we included relative at our body. We continue now with the styling of our call notification UI right here. bg will be set -500, let width be screen. So this will be the parent div for our call notification, and we want the background to be transparent. So we include this bg, but we'll also have an opacity. So we'll say bg -opacity to be 70. So it will be transparent. Then with screen and h screen, it will occupy the entire screen. 0 and bottom 0. We will flex, and we will have items to be at the center, and we will justify center. Up to this point we are not sure if our call notification will work or not, but to test this, let's just say here someone is calling, just that. we'll go to our app, then page, and here is where we will hook up our call notification. So here I'll say call notification. Did we export it? Why are we not getting a suggestion? We should get a suggestion for this. It will come from our components, call notification. Very nice. Then at call notification, we should say that this particular component is a client component since we made use of this hook. So at the top here, we'll say use client, and I go ahead and save. So at this point, we can test the app and see if we get this someone is calling. I have two browsers already open. I have two users, this one and this one. Okay, they are both reloading. I'll wait for them to complete. There we go. Now when we click this, we should emit a call event to the server. The server will emit an incoming call to the person that we have tried to call, which is this person. So I click and nothing happens. So that means that we have an issue. So let's inspect first and see if we have any errors here. No errors. So I have found out the issue. It's pretty small. Here we said socket ID with a small I instead of a capital here. So socket ID like that. Now this is one of the good thing of using TypeScript. Since here we are using JavaScript, it does not warn us that there is nothing like socket ID with a small I, but if you are using TypeScript, it would have told us. But we fixed that, and let's test the UI again. I call, and now look, we have this dark screen right here, and it's saying here someone is calling. And right here we said top 0, and instead of bottom 0 we should have said left 0, so that that dark UI will touch the end here. So let's see, have I saved? I'm not sure if I've saved the file, but I want it to be at the very end here. And another thing, it should be transparent. I don't think it's transparent right now, so something is still up. Opacity, okay, opacity there 70. So I had misspelled. I save again, and now let's check. So I refresh and I refresh here, and now when I call, it's transparent and we have this someone is calling. So here we'll design this UI in the next episode, since this episode is already long enough. So I'll see you in the next one. Hey, hello everyone. So in this episode, we'll just go ahead and design our call notification, since in the last episode we were able to emit the events and so on, and we showed this particular call notification UI. So let's just continue where we left it and design this. Right here we'll just add a div. I'll say class name, and here we'll have bg is white, then main hyphen width will be 300 px, then right here you'll have main hyphen height will be 100 px, flex as call items at the center, and right here I had said item instead of items, so items center. Then we justify here to be center, then we say rounded, and padding or round to be 4. Inside this div is where we'll have details about the call notification. So I'll have another div, and I'll include an avatar component which we had already created in the previous episodes. So here I'll say avatar, and I bring that from avatar. Then it will expect us to have an src, and here we'll say it's from our ongoing call, then dot participant dot caller. So we are showing the details of the person who is calling, dot profile dot image URL. We show a h3, and it will now be the name of this person, which we had done earlier when listing the users, and we said online user.profile.fullname.split by space, then we get the first name. So we do this actually because sometimes the last name is there, sometimes it's not, sometimes the first name is there, sometimes it's not. So we just take the name that will be available by doing this. So here I include the curly brackets and I do this. Now instead of online users, here we'll say ongoing call, then dot participants dot caller, the person who is calling, dot profile dot full name, then is split like that, and I go ahead and save that one. After that, I'll have a paragraph and I'll just say incoming call. Right here, I'll style this a bit, so I'll just add a class name and I'll say text is small, then margin to the bottom is 2. Then right here, I'll add a class name and I'll say flex, then flex will be call, and I'll say items center. Now right here I'll have a div. Here we'll have two buttons, one to accept the call and the other one to hang up or to end the call. I'll say button. I'll include an icon from React Icons called MD call. We import that from React Icons MD. I'll close this one and I'll give it a size prop. I'll say size is 24. Very nice. We'll have a class name here, so I'll say class name, and width will be 10, height will be 10, then BG will be green hyphen 500, it will be rounded full, so it will be circular, rounded full, flex, items center, and we justify center. Very nice. Finally, we'll say text white. That will make the icon to be white, text white. So that is our green icon. We can duplicate it and have a red one. So here I'll say rose. The styles will be similar, but here we'll say call end. So we change the icon, we import it, and that will be it. Now both will have on-click events. The first one will be to answer a call, this one will be to end a call, but for now we are just focusing on the UI, so I go ahead and save that one. So let's see now what we have. Once we get a call, we see a UI like this. Let's refresh because we are not seeing the answer and the end. Okay, so here I call and I get this UI. Okay, something is wrong. Okay, we get the buttons. Where are the styles? The styles have come. Okay, we should fix these still. So we come to this div and we'll add a class name and we'll say flex and we'll have a gap of 8. Yeah, I think it's fine now. Let's see how it looks like, and we'll get a call notification like this one. Now we'll be able to answer or end the call. So I'll leave at this so that in the next episode we'll start talking about WebRTC. So I'll see you in the next one. Hello everyone. So in the last episode we were able to work on our call notification UI such that when we click an online user here, we initiate a call to them and we see this incoming call UI. And in this particular episode, I want us to start working with WebRTC, and that will involve getting the video going here for the calling user. And later on, we'll see how when we answer here, those two users will be able to communicate. So for now, we'll focus on getting the video and the audio. So if I go to WebRTC docs and I go to the overview here, we have an intro here about WebRTC. And you'll see the WebRTC standard covers on a high level 2 different technologies: the media capture devices and the peer-to-peer connectivity. So right now what we want to start with is this right here, media capture devices. How can we be able to get the video going on and the audio? And then later on we'll see about this peer-to-peer connectivity, so that when we already have the media or the video being captured, then we'll be able to connect those two users and then they'll be able to communicate. Okay, so you can go ahead and go through these docs. If you want more information about WebRTC, just search for WebRTC and you'll see all this. And to capture the media, we have this particular method right here, get user media. And also for screen recording, we have this get display media. Now, first things first, when we click on an online user, we will be calling this particular function right here, handle call. So when we click this handle call, that is when we want to get the video, the audio, and we'll be calling those media stream. So we want the stream whenever we click that particular user and we call this particular function. So right here, okay, maybe after this return, we will just say const stream will be equal to, we await, and we will call a function get media stream. So we don't have this function, but we are going to create it in a minute. And since we have used await here, we should make this callback function that is right here to be an async function. So here I say async. Then we create now this get media stream. I'll do it at the top here, and we can say const get media stream to be equal to, let's make use of the use callback hook. We invoke that, we pass an arrow function right there. We will have dependency array. We'll be able to call this function again if our local stream changes. So this local stream will be available in our state, and I can come right here and define it. I'll say const local stream and set local stream, and this will be equal to use state. We will have a type here. The type will be of media stream, or it can be null. Here we will invoke our use state and we'll say null to begin with. So what have we done? I have defined this particular function get media stream. We make use of use callback. We'll have an arrow function and a dependency array. The dependency array here will depend on local stream, and we add that to our state there. So local stream is our own stream. Okay, so this arrow function that we pass here will be an async function, and I'll go ahead and say async in the body of this function. First of all, we check if we have a local stream. So if we already have the stream in our state, we will check and immediately return that stream. And again, I have told you the stream will have information about our video and also the voice. If we already have a local stream, we return that stream and we'll be able to get it right here as a stream. Else, if we don't have the local stream, we'll go ahead and get the local stream. And right here, I'll use a try and catch block. So I'll say try, catch, and at try, we will get the devices. So I'll say const devices is equals to, we await, and I'll say navigator dot media devices, then dot enumerated devices. So devices, sometimes, for example, for the video, you might have different inputs. For the video, you might have the camera that is inbuilt in your computer. You can have a camera that is plugged with a USB. So we have like many devices. Also for voice, the same way, you might have a mic that is plugged in, or the built-in mic, and so on. I only want the video devices here, so I'll filter out to get the video devices. Const video devices will be equal to, I say devices dot filter. Here we will get a device at a time, and we'll be able to return the device dot kind is equals to video input. We could be having two different kind of devices. For example, if you have a phone, you have the selfie camera and you have that back camera. So those are two video devices. And if we have two video devices, we would prefer to get the device that is for the selfie because we are doing like a video call. So we can use this. We check the one that is for the selfie and we use that for the video call. I'll get the media stream and I'll say const stream, and this will be equal to, we await navigator dot media devices, and then we get the get user media. So this stream will contain the audio, the video, okay? But here now we can set the default configuration that we would like for our stream. First of all, we will have the audio. So we'll say audio true. Then it will have the video. And here we can set the settings for the video. Then we'll say here facing mode. So the facing mode value here could be undefined. It could be user. When we say user, that means that we prefer the video that is for the selfie camera, that is. And if we say environment, that is for that back camera. So here just say if we have more than one video devices, then we prefer the face mode. So this face mode, you can pass it as a parameter. So what I mean is that we will be able to pass it right here as a parameter. So I'll say face mode, and this will be an optional string. The string value could be user or it could be environment. So here I do this, and you could use this to perform like a toggle between the cameras. If you have more than one, you could be able to toggle them. So I'm just showing you this, but I don't actually think that we'll be toggling the cameras and so on, but you could do that. Now here we will get a stream, and this stream have our video and the audio, and we could be able now to return that stream. So here I will be able to return the stream. So if we call this get media stream, we return that stream that have the audio and the video. And also before we return, we could set it to be our local stream. So set local stream to be stream. So if we have an error, I think we could console log here failed to get the stream, and we could show the error here as error. Then we could reset the state right here. We return something as well. So what we will return here is null. When we return null, that means that from get media stream, it returns either a stream or null. So if we come to our handle call, this stream might have the stream or it might not have the stream. And we should cover a case where when we don't have a stream, okay? So we perform a check. We say if we don't have a stream, then we will immediately return. That means that we will not proceed by emitting this particular event that makes a call to the other user. And the situations where we might not have a stream is, for example, if we don't have a camera plugged in, or if our device camera is not working for some reason, or if we decline the permissions for the camera. And also here we could console log an error. No stream in handle call. Now we can be able to check the state. If we have a stream, we show it on our UI. If we don't, we don't show it. But at this point, we should be able to have the stream as state and perform this check. If we don't have it, then we will not like give permissions. So I think we could test and see how this is. And now if I click this user, we will make a call to this function. This function will make a call to get media stream. Get media stream will try to get the video device, the audio, and so on, and it will give us a pop-up if we want to give permission. So let's see if it does that. I click, and look, we get a pop-up to give permissions to the camera. So here I allow, and once I allow, you'll notice that right here we get the call, and right here at the top it shows that we are giving permission to our camera. This means that we are getting our local stream, and we should try and display it here and see if it works. So the first thing that we will do is to add this local stream to the value of our context. So I'll come right here and I'll say local stream. We add the type first. It will be of type media stream, or it could be null. We take now local stream and we add it to our value. So I say local stream. This means now we will be able to access it anywhere in our application. I'll add a component. At components, I could just do it at the root of our components, and I'll say video call.tsx. I'll say stateless functional component, and this will be video call component. And at the top, we'll make this to be a client component. So I'll say use client. Right here before our return, we will be able to get our local stream. So I'll say const. Okay, we destructure it from our use socket hook. So here I do this and I set this to be equal to use socket. I invoke that, so we get our local stream from that hook. We will be creating another component that will have our video. So let's add a component, and I can say video container.tsx. Here I'll say stateless functional component, and I'll say video container. We will return a video now. So video element. This video element will have a class name, rounded, will have a border, and will have a width of about 800 px. Autoplay, that will be true, and then plays inline, and we'll say muted if it's local stream. We'll be having this flag. So this flag, if it's local stream, will enable us to know if it's our video or it's the video for the other user or the person that we are calling, because we'll use this component for both. Then right here, we'll be able to receive a stream. We'll be able to receive is local stream prop. We'll be able to receive is on call prop, and we should add the types for them. I'll say interface I video container. We will have a stream of type media stream, could also be null. We'll have is local stream, then here I'll say it's boolean, then we will have is on call, and here I'll say boolean. So this is on call will be true when the other user accepts the call and he does not like hang up. If he accepts the call and we are on call, we'll make our own video to be small at the top, and then the other person video will like occupy most of the space. So that is the use of this is on call flag. Okay, we add the type here. I'll just say full colon, and we'll say I video container, and we save to auto format there. Now I come right here. We will set the SRC for this particular video by making use of ref. This is how we'll do it. I'll just say const video ref is equals to, we make use of the use ref hook. By default it will be null, but the type here will be HTML video element, the type for that. And then now we assign that ref to this video, which is our HTML element, and we'll say ref, and we say video ref, this particular ref here. Use ref, we bring it from React like that. If we have a stream, we will assign the SRC for the video to be that stream. So here I'll say use effect, and we will invoke this like that, and we'll have the dependency array. The stream will be our dependency. If stream changes, this use effect will run again, and right here we'll be able to perform a check, and we'll say, do we have our video ref dot current, and do we have a stream? If we do, we just assign the stream to our video ref SRC property. So I'll say video ref, then dot current dot src object to be our string. Now we used src object because this string is an object, and once we do that, this will show us the video. So I save. So we come back to the video call component. We will be able to show that video container, and here we will perform a check. Do we have a local stream? If we do have a local stream, we'll go ahead and show our video container, and we import that from video container, and these expect several props. The first one is a stream, and in this case we are showing the local stream, so we say local stream. We will have is local stream, which is actually true. Okay, so is on call. For now we will say false, but later on we'll be performing an actual check to see if we are on call or not. For now I say false, so we'll be changing that value later on. And once we do this, believe me not, if we have a local stream, we'll be able to see the video going on. So we come to app and we come to page, and we hook our video call component right here, video call. Okay, we should import it. So we get a bunch of errors because we didn't import these, and I save now and we refresh. So now let's see what happens. So we get local stream as null, many renders, but now let's call, and voila, we get these. And as you can see, we are getting the video here. Okay, the reason why it's dark is because my camera is crossed, but let me open and you see, there we go. So you can see my video is there. Very nice. I think for now I can leave it at that. We are able to get the media stream going on. And what I'll do in the next episode, we will implement the functionality for toggle. Okay, we can toggle the camera, we can toggle the audio, and so on. And then after that, we'll see how we will go on to the peer-to-peer communication. So for now, we have covered the get media stream part of WebRTC API. So that is the first thing, and I'm happy with it, and I'll see you on the next one. So in the last episode, we were able to implement getting the video and the audio such that when we initiate a call right here, that will notify this other user that there is an incoming call. And then, as you can see down here now, we are able to have our video going on. Now, in this particular episode, I want us to add some buttons which we will use to toggle the video and the audio, and that will be it for this particular episode. And we will do that in our video call.tsx component. First of all, in this particular video call.tsx, I'll add some state. I'll say const, I'll have some is mic on, set is mic on, and then right here you'll have use state to be true. I'll duplicate that one, and right here I'll say is vid on, set is vid on. Let's bring in our use state. I'll create a few functions. So I'll say const, and I'll say toggle camera, and these will be equal to an arrow function. Then in here we will check, do we have a local stream? If we do have a local stream, we'll go ahead and get a video track from our local stream, and we'll do it like this. Const video track will be equal to our local stream, and we'll set dot get video track. Okay, we'll get all the tracks that are there, then I'll get the very first one like that. And this video track has a property called enabled, and that is the state that we will change. So if it's enabled, we will toggle it to be not enabled, and vice versa. So here I'll say video track dot enabled. We will change that to be the opposite of video track dot enabled, so it's a toggle. So if it's true, it becomes false. If it's false, it becomes true. Then right here we set the state. Set is vid on, and we'll set that to be video track dot enabled, just like that. And we have this function which we will use to toggle. You could optimize this particular function by making use of use callback. So right here I can say use callback. I invoke there and I close this arrow function to be inside our use callback. Then here we'll have a dependency array, and I'll say local stream, because that's what we are depending on right there. I go ahead and save that one. I'll create another function which will be similar to this one, so I'll duplicate it. Alt Shift bottom arrow to duplicate that at the bottom here, and right here I'll say toggle mic. Then here we'll have our local stream, and we will get our audio track. So audio track is equals to local stream dot get audio tracks, audio track dot enabled. Then we will toggle the value for audio track dot enabled by making use of this exclamation mark. So we toggle it like that. Then we update our state. This will be set is mic on to be audio track dot enabled. So use effect here. Then here we will be able to get the track and update the mic and the vid, just like we have done right here. So it's a similar thing, only that these will run at the time our component renders. So here I'll say local stream. We perform a check like this. So it will be a similar thing. The only thing is that we will not toggle this value. We will just get the track and we update the state. So we will do that for this as well. And I think that will give you the correct value. So don't toggle. So I think that will be like this use effect will give you the correct state of whether your mic is on or not, and then you can be able to toggle them depending on that. So I'll just come now down here and we'll add our UI. This local stream is in this div. I think we could add a div for that section, for this particular local stream there. So I move that to be inside a div so that we can add another div here for our button. So I'll do like this and say button. So for this div, I'll add a class name and I'll have margin at the top of 8, then flex and items to be center. For this button, now we'll have an on click. I'll say on click. Then we will call our toggle audio, the function that we just created at the top. Okay, toggle mic. So here we will perform some check, and I'll say is mic on and MD mic. We include a size of 28. So this MD mic is a component from React icons MD. So I import it. The import will look like this. So if mic is on, we'll show this particular icon. If mic is off, we'll show a different one. Here I'll say is mic on. I use this exclamation there, and here we'll show MD mic off component, and this again is from React icons. And right here I'll include the size prop and I'll say 28. Now this button is for mic. We will have another button here. It will be for ending a call. End call. I'll have a class name and we'll say padding along the x-axis of 4, padding along the y-axis of 2. Then I'll say bg to be rows 500, text to be white rounded, then mx to be 4. We will have an on-click event, so on-click, and later on we will implement this particular function, but right now we'll just return an arrow function which does nothing. So here we'll have a method for hanging up a call, but for now we'll just have this. At the end here we'll have another button now to toggle the video. We will perform some checks similar to these ones. Let me copy, then I'll fix them. Then right here we'll be having an on click event, and for this on click we will call our toggle camera. Then for this one we'll say is vid on and is vid on here. Actually I think we kinda messed the icons, like they should be, this one should be here, this one should be here. When the video is on, we want to see the icon for turning it off, okay? And when the video is off, we want to see the icon for turning it on, the same way in this. So right here I'll show the icon for turning the video off. So I'll say MD video off. Okay, video cam off, size 28. Then right here I'll say MD video cam, just that. And for this one, this I'll say off, and this I'll leave it to be on. So the point is, when the mic is on, we want to see the icon for turning it off, and then when it's off, we want to see the icon for turning it on. I hope that makes sense. And I go ahead and save, and then we'll see those icons right there. Now later on, we'll only show these icons only when we are on a call. Okay, so let's just initiate a call and see if they work. We'll test them out. Okay, I call this user and we get the call going like that. We have this notification, and at the bottom of our video we have these. We should make them to be at the center here, but for now they are here. And if I happen to click this video icon, look, we are able to hide the video. If I click it, the video is on. If I happen to click this one, this now will mute the user or unmute the user. We had used flex right here. Let's see where the flex goes up to. So we can say a BG of straight 400, and you see if it gets to the end here. And if it does, then we shall just come right here. Should we add justify center? I think that is the one that will fix that. I save, and this should move here, and there we go. So now I remove this BG. This was just to check the position for that. And yeah, that is it. That is how we can implement the toggle. Now in the next episode, I'll focus on answering a call. Okay, so we answer a call, and we'll see that peer-to-peer communication in WebRTC. So I'll see you in the next one. Hello everyone. So in this episode, we'll start talking about WebRTC peer-to-peer communication. And I figured out that when we start talking about the peer-to-peer communication, we'll be having so much back and forth going on between our client and our WebSocket. So I figured out that it's good I come up with this particular diagram that simplifies everything that is going on and will be going on in our application. Therefore, it's very important, if you are following this course, you get to understand this diagram, because it will simplify everything that is going on in our application, and that will make it easy for you to implement peer-to-peer communication in WebRTC. So in this episode, I'll just go through this diagram, and then in the next episode, we'll start to implement some of the things that are going on in this particular diagram, although we have already implemented some already. To begin with, we have a client 1 here and a client 2 here. And what we have already implemented is that client 1 can make a call to client 2, and client 2 can see that notification of an incoming call. So what happens is that client 1 emits the call event to our socket server, and this socket server is our signaling server. Our socket server emits the call notification event to our client 2, and client 2 can now see a notification on the UI. We implemented that, and they have two options. They can either answer the call or they can hang up the call. If they happen to hang up the call, we basically stop everything. But if they happen to answer the call, we will do something, and this is where we start now handling the peer-to-peer communication in WebRTC. And the thing that we will do is that we will create this peer, and a peer basically will contain information about the call, like the media, video and audio, and then it will contain some signal information, whether the signal is on, whether it's off, whether there is an error. So that peer is very important in this case. So we create this peer 2. Okay, once we create this peer 2, we will emit an event to the server, and that event will be this offer. We emit an offer to the server, and that offer will contain what we call the SDP data. SDP data is the media data, video and audio, and other data that might be necessary. So we emit the SDP data to the server. The server will emit that SDP data to this client 1. Okay, once client 1 receives SDP data from this peer 2, we will know that this peer 2 answered the call. Like remember we had made a call, they saw notification. Once we receive the data, we'll know that they have answered our call, they didn't hang up. Okay, once we receive and we know that they answered the call, what we will do, we will create now peer 1. Okay, we create peer 1 and we emit an event to our socket server, and the event that we will emit is an answer to the offer. So remember, this emitted an offer, then this will emit now an answer to that offer, and what that answer will have is the SDP data for peer 1. Okay, and then WebSocket will emit the answer to this peer 2, and once peer 2 receives the SDP data from peer 1, we will complete that peer-to-peer connection. Okay, and once that peer-to-peer connection is complete, peer 1 will be able to directly share data with peer 2, and that data is the video, the audio, and so on. So they'll be able to communicate through the video directly. And we have something else that is going on here. When creating a peer, we will also configure what we call stun server, or you can also configure a turn server. And these servers are actually already available for free. Google provides some and we'll configure them. I think even Amazon have some, but we'll make use of the Google ones. We will configure the stun server when creating a peer, and you could also configure a turn server. And what stun server does is it will decide the best network path for the peer-to-peer communication to go on, and that network path in WebRTC is called an ICE candidate. So when learning WebRTC, you might come along ICE candidates. So we configure the stun server, and the stun server will decide the best network paths for peer-to-peer communication to go on. And with stun server, data does not go through the stun server. What stun server does is only determine the best network path, and then that network path will be between peer 1 and peer 2, and they can be able to communicate directly without going through the server, and that is very, very efficient. But sometimes that might fail because of things like firewall. If we have some firewall and the stun server is unable to identify the best network path because it can't find some IP addresses and so on, so we use turn server here as a fallback. And a turn server will enable peer-to-peer communication, but in this case the data must go through the turn server. Okay, it will not be direct. So peer 1 will send data to turn server will send data to peer 2, then peer 2 can send data to turn server can send data to peer 1. So turn server will allow the two to communicate, but the data must go through the server. But with stun server, that determines only the best network path, and then peer 1 can directly communicate with peer 2. So when we have that direct connection, that means that it's more efficient than the turn server. Turn server is just for a fallback. But basically, this is everything that will be going on in our application. Okay, we make a call notification gets here, then once we answer the call, we create a peer and emit an offer containing the SDP data to peer 1. Peer 1 will receive the SDP data for peer 2, and we will know that peer 2 answered our call, and therefore we emit an answer in peer 1. We create peer 1 and we send an answer containing the SDP data for peer 1 to peer 2. In peer 2, we will complete that connection, and then the two will start communicating. Okay, very nice. Now the next episode we will see how we can create a peer, and then later on we'll see how we can emit an offer. So the next thing to do now is to see how we'll create a peer and emit an offer. Okay, but basically this diagram summarizes everything that is going on in our application, and also summarizes the WebRTC concept of peer-to-peer communication. So if we proceed and things start getting confusing and so on, you can always come back to this diagram and then you'll see light. So that is it for this video, and if you're enjoying the course and you are enjoying my videos, support my channel, subscribe, share, and leave a thumbs up, and I'll see you in the next one. In this episode, we will continue working on our real-time video call application. And just to show the progress, right now, if I click right here, the online user, I'll be able to emit a call to this other user right here. And what I want us to do is to handle this answering a call, okay, in this particular episode. And things might start getting confusing as we move on into the code. And if in any case things start to get confusing, I covered this particular diagram in the last episode, which explains everything that is going on and will be going on in our application. And if you get lost, always come to this diagram or to the last episode, and you will be able to understand, how things are going. And right now, what I want us to do is to create a peer and emit an offer to our server, and then the server will send that offer to this other peer. Because so far we can make a call which gets to the server, submits that call notification to this peer, and that is why we are seeing this call notification. And then once we get this, we can either hang up or answer. If we hang up, we just stop everything. If we answer, I want us now to proceed to the next step. We will create a peer and we will emit an offer. So let's get started. In the code, I am in call notification. We had this button for answering a call, which is this one right here. And this is where we will begin everything. And we will have an on-click event. So I'll say on-click. We will have an arrow function that will pass. And we will handle join call. This handle join call will receive the ongoing call. We receive that ongoing call. So this handle join call function, we will create it in our use socket, and then we will bring it in right here. So let's do that. I'll come right here and I'll go to the context and then socket context. In socket context, just scroll up to where we have some use effects right here, and we'll do it just at the top here. Okay, so I tap there, and here we'll create that function. I'll say const handle join call will be equal to, we'll make use of the use callback hook to optimize this particular function. I invoke it. This use callback accepts a function right here, and at the end we'll have some dependency arrays. Here the dependency array will be the socket, and we'll be having current socket user as the dependency array. Right here we will be receiving an ongoing call, and this will be of type ongoing call. And in here is where we will do stuff to handle the joining of a call. So join call. So up to that point we have just created this particular function. We will export it, or we will add it to the value of our context. So to add it to the value, first of all, we come at the very top where we have iSocket context, and we will add it to these types. I'll have handle join call full colon. This will receive an ongoing call of type ongoing call. So this is with a small o, and then this is with a capital O. This is the type. This is what we will be receiving. We will be able to return void. So we return nothing. Very nice. Now, once we do this, you'll see that our value here complains because it expects us to pass our handle join call. So we pass handle join call right there, and they save. So now if I come back to call notification component, we will be able to receive our handle join call right here. So handle join call, just like that. And as you can see, the error disappears. Now we can call that function here. We pass ongoing call here, and just like that, we have now our ongoing call right here in our function. If I say console.log of ongoing call, we'll get our ongoing call. So I save, I call. Here we are having the video going on and so on. And here we click on this button to join a call. So let's come to the console and see if we get our ongoing call. So I click on this one. Okay. Yes, I click and we get this ongoing call. We have is ringing, we have participants, the person who called, the person who received. So we are getting that. So far, so good. Now, once we answer a call, the first thing that we will do is to set the is ringing state to false. And that will just hide the call notification UI. Set ongoing call. Here I'll have a previous, and right here, if we have the previous, we must return something. So we will return, we spread previous, and we will edit is ringing. So previous is the previous state, and we update the is ringing state to false. Okay, now this is if we have that previous state. If we don't have the previous state, we'll just return. So I'll say else here, or not even else, just at the bottom here, you can just say return previous. The second thing is to get our stream, our local stream. Okay, and for this other user, you can see we have this stream, video stream going on, but for this one we don't have that stream. So we get the stream for this user now. Okay, and we had created a function for getting a stream, so we'll just call that function and we make use of it. So after setting that, we'll come here and I'll say const stream will be equal to, we await, and we'll say get media stream, and we invoke that. And you know, in this particular function, we were setting that local stream to the state. So this get media stream here, we were also getting the stream and setting it to our state. So we'll get the local stream going for these other users, so they'll be able to see their own video. But for us to send that stream to the other user so that they can see you, we'll now create a peer, and that peer will contain the stream. So right here, this will set your local stream, but we'll make use of this stream to create a peer. So await complaints, but that is not a problem because here we just need to say async. First of all, if we don't have a stream, we'll not continue with joining the call. You might not be having a stream, either you don't have the camera connected, or the camera is in use by another application, or you have disabled the camera, or for any other reason, we might not get the stream going. So here we say if we don't have this stream, we'll just immediately return. So we will return, and we can console log right here for us to see that this call didn't go on because we didn't have a stream. So could not get stream. You can specify the function in handle join call. If the stream is there, we'll go ahead and we will create a peer. At the top here, I'll create a function that will help us to create a peer. I'll say const create peer will be equal to use callback. So to optimize this function, we make use of this use callback. We pass an arrow function here, and here we'll have some dependency array. Now for the dependency array, if ongoing call changes is when we'll be able to call this create peer again. So ongoing call, and that means that this function will not be created on every re-render. Only when ongoing call changes, the function will be created. Okay, and that saves on memory and so on, makes our app much faster. The first thing that we'll receive is the stream that we created, and this will be of type media stream initiator. Now initiator is like the person who is creating the offer and emitting the offer, and then the other person will be answering the offer. So the person who created the offer is the initiator. We'll have this as Boolean. So for these to work, we'll make use of a library called simple peer. So we need to install that particular library. npm I of simple -peer, and I hit enter. So as this installs, I'll come back to this create peer here, and we will be needing to configure some ICE servers. And the iServers include the turn server and the stand server, like I showed you in this particular diagram. We are at this step. We want to create a peer, and when creating a peer, we will configure these stand and turn server. This is what we are calling the iServers, and they will support this peer-to-peer communication. So right here, I'll just say const iServers, and we have some free iServers that are available in Google, and we'll make use of those. So here I'll say these will be of type RTC iServer, and these will be an array. So we set this to be equal to an array, and in here we'll pass an object and we'll configure the URLs to those servers, and you can copy these URLs exactly like I will do. So URL will be an array, and we say here stan stan.l.google.com :190302. So stan.l.google.com :190302. So there are several of them with a similar URL. You can duplicate these 4 times, and then you'll have stan. These now will be stan1, this will be stan2, this will be stan3. So we have stan1, stan2, stan3. So those are our iServers, and we'll come now down here and we will create a peer. This completed installing that library, the simple peer library, and we will say right here const peer will be equal to new peer. We use this class. This peer right here will come from that simple peer library, but it's already complaining. I'll click at the end and try to import. Okay, it doesn't give me the suggestion to import, so let's import it manually. And I'll say import, and I'll say peer, we'll say from simple peer. So what we need to do is to run npmi, and we save the types as dev dependencies. So I'll copy that and I'll install the types. And then down here now at create peer, we'll pass some options here. The first one is the stream that we brought in right here. So we say stream, comma. The other one is the initiator that we also bringing right here. Trickle to be true. Trickle here means that during the peer-to-peer communication, the iServers will be shared as they get discovered. Okay, it will not wait for all of them to get discovered so that it start sharing the data and so on. Config our iServers. I pass our iServers right here, which we set up right here. So we pass them right there, and just by doing that, we have created this particular peer. The peer will be able to listen to some events. Okay, the first one is the stream event. So peer.on, and here I'll say on stream, and this stream event is when we receive the video data, the audio data from the other person who like answers our offer. Remember here we will emit an offer. When the other person answers the offer, they'll be able to send us the video, the audio, and so on. So we'll get that stream right here as a callback. So stream, and here this is an arrow function, and what we want to do is to add this data to our state. And once we add this stream to the state, we'll be able to show that video for the other person on our UI. So now we'll be having 2 videos, our local stream and this stream that will come from the other person. Okay, I hope that makes sense. So here we'll be having some piece of state, and I'll say const peer and set peer. This will be equal to use state, and I'll invoke that. I'll say null, and then right here I'll have this as a type of peer data, which we haven't defined yet. or null. Now I think we had a file with the types. We had this file. So we go to that ongoing call, and down here we will define the type for the peer data, the type for our peer. Export type peer data will be equal to, and right here we'll have a peer connection. We'll set that to be of type peer.instance. I think we need to bring in this peer. Okay, let's do it manually. Again, it doesn't auto import. We'll say import peer from our simple peer. So this peer connection will be of type peer.instance. The stream will be of type media stream, or it will be undefined. Okay, very nice. We'll have participant user, and this will be of type socket user. Okay, we do that. Then we come here to our socket context and we bring in our peer data, which we just created from our types. So our peer will be of type peer data. Peer data will have peer connection, stream, and participant user. So now that we have this state, we'll come now here, and once we get a stream, what we want to do is to update this stream right here, which will be part of our peer. We'll just say set peer, we invoke it, and we will pass an arrow function like this, and here we will receive the previous peer. And now inside here we will say if we have the previous peer, we will update that peer. What we will do, we will return, and what we will return here is our previous peer, but now we pass the string. If we don't have the previous peer, we will just return right here. So we will return our previous peer just like that without adding a string. And we can add this set peer at our list of dependencies. So I'll say set peer. Okay, so when we receive the stream or the video, the audio from the other user, we will add that to our state here, and then we'll be able to show that on our UI. So this is the first event that we can listen to. So here I'll say peer dot error, and here we'll just say console dot error, and right here now we'll also have peer dot on and close. For example, if the other person maybe closes their window and they are no longer, online, and what we will do is to handle hang up. So we don't have this function yet, and we will not cover it in this particular video, but we'll just create it. Okay, and here we'll just create that function. Const hang up will be equal to an arrow function. Maybe we'll make use of use callback as well, and we'll have an arrow function there that will handle our hang up. Okay, so dependency array, this will receive an object that will have some stuff in there, and we'll cover that in the next video. So handle hang up. If they happen to close, they happen to hang up, they happen to close the window, we will call this hang up, which will clear everything and will no longer be on call. Very nice. So up to this point, we have created a peer. We have recents to these events, which are very important. Right here, I'll just say const, and we'll have RTC peer connection of type RTC peer connection, this one, and then we'll say this is equal to, and we'll say in here peer as any, to bypass any TypeScript issues, and then right here I'll say dot PC. So this PC holds the connection, so we get that connection right there. And then now right here I can say RTC peer connection, then dot on ice state change. This is the change of the ice servers, and we'll set that to be equal to, here we'll have a function and we'll do something in here. If we have a change, we'll get this async function going on. And inside this particular function, what we will do, we'll say if the RTC peer connection dot ice connection state is equal to the disconnected state, or if the RTC peer connection dot ice connection state is equal to failed, so it failed to connect or it disconnected from the ice servers, then we'll go ahead and we hang up the call. So we'll say handle hang up, just like that, and later on we'll implement this handle hang up further so that we complete whatever we are passing right here and right here. So for now we'll leave it at that. And with this we have been able to create a peer. And one thing that we are not doing is that we should return that peer from this particular function. So we have created it, we are listening to several events. If we have a stream, we add it to peer in our state. If we have some errors or we cross and so on, we hang up. And then at the bottom, after this now, we will return that peer, okay? Return peer. And I save. Now, remember, we were at handle join call, and after this string is where we want to create the peer. So we have created that function, but we are not calling it yet, so we should call it. We will say const, and we will say new peer will be equal to create peer, and we will invoke it. And why are we getting an error? Because we expect some arguments. Okay, in here we will have the stream. We'll also have true as the initiator. Set peer, and we will pass this object. We will say peer connection is new peer, and then we'll say participant user is our ongoing call dot participants dot caller. We will set stream as undefined, because we don't have the stream for the other user right here, but that stream will be updated whenever we get this stream event, and then it will update that stream for the other user, and we will get it at our peer. Note that we have this stream. This is for the local stream, the person who is like currently running this function. And then when we get the other stream, that will come through our peer, and we will resend to that event right here. And then we will set that to our state, and we will get the updated state. So here we set the state, and this will be updated whenever we get that event. When peer is ready, we will get a signal, and we will resend to that event. So we'll say new peer dot on signal. Here we will pass an arrow function, which we can do stuff with it, a callback function, and this can be async. We will receive data, and that will be the signal data. So of type signal data. This signal data type will come from our simple peer library, signal data, and the signal data is like the SDP data and so on. So basically, when the peer is ready, we'll be able to have this event, we resend to it, and then we will get that data, the signal data. And right here we will perform a check. If the socket is ready, our socket IO, if socket is there, what we will do, we will emit an offer now to the person who called us. So we'll emit a WebRTC offer. So here I'll say console.log, and here we will be emitting an offer, or you can just comment, okay? Emit offer. So right here we'll have now socket.emit, and we will emit WebRTC signal, WebRTC signal to the server, and then the socket server will emit the data that we pass here to the person who called, okay? And then the person who called will respond with an answer which will contain his SDP data and the stream and so on. And then once it comes back to us, we'll be able to complete the peer-to-peer connection and the video call will start flowing on. So again, if you get confused, go back to the last episode where we had that diagram. So here we are emitting the offer and we pass the data and we'll have SDPS data, and that data is this one here, which we get from our peer signal there. And here we'll have our ongoing call right here for more information about the call, and we'll say is caller here will be false. So the person who is emitting this offer is not the person who called, it's the person who received the call, and then they'll emit a WebRTC offer. So that is our handle join call function, and this episode is long enough, and in the next episode we will see how we can complete this peer-to-peer connection. Hello everyone. So in the last episode we were able to create a WebRTC peer, and we also emitted an offer to our server. So we mainly created this function here, handle join call, and in this particular video I want us to complete the peer-to-peer connection, and then in the next video we'll be able to show the peer or the video for the other person. So far we are getting the local stream for this user, and if I happen to call, if I click this to call, we get a call notification here, and you can see we have a video here, and if I happen to answer, you'll see we also have a video here. So this is the local stream for this user, and this one is for this user. It's the same because I'm using the same camera, and the thing is here I'm on Chrome, and on one it's the normal, and then the other it's on incognito, okay? Because if you use like 2 tabs for Chrome, you'll complain that the camera is already in use. But if you use incognito, you can be able to, you know, show the 2 videos like that. The last step that we did is to emit a WebRTC signal to the server. So we need to receive this signal or listen to it on the server. So here at the root of the application we have server.js, and at server.js here is where we had some core events. We'll say socket.on, and we will get to listen to a WebRTC signal, and very important that this must be the same as what we emit here. So always make sure that this spelling is the same, and if you need to, you can even like copy paste that so that you don't miss the spelling. So I copy paste that one, and then right here we will call on WebRTC signal function. So we create this function, and on the server you can see it doesn't complain because we are using JavaScript. If we come now to socket events, we can get to create that particular function, and we'll say on WebRTC signal .ts, okay, .js. On the server we'll use JS, and here all we need to do is to emit an event to the person who called us in this case, and we will forward the SDP data that we had set up. If we come back to socket context, we want to send this data right here to the person who called us, okay? And another thing that I need to mention is that once we get the data on the other person, we will also emit a WebRTC signal back to us, that is, and that will be the answer. So we'll emit back the answer, and the answer will contain similar data. So this on WebRTC signal will have 2 parts. One is for the person who called us, and the other one is for us, okay? Because there will be that back and forth. So the first thing that we will do here is to import IO. So I'll import IO, and this will be coming from our server file. Then right here I'll say const on WebRTC signal will be equal to, we will have an arrow function. This arrow function will receive the data, and the data is this data right here. This particular object is the one that we will receive as data right here, okay? So here I'll say async, and here we will receive that data and we'll do stuff with it. And from our here, we had specified that the person who emitted this particular event is not the caller. So we'll make use of this is caller property to know whether it's the caller who emitted the event or not. So in this case, this is not the caller who emitted the event, and we'll make use of that right here. So we'll say if data dot is caller, then we'll do stuff right here. Else means that it's the receiver who emitted the event, we'll do other stuff right here. And since it's not the caller who emitted, means that this else is the one that will be executed in this case. And you'll say if data dot ongoing call. So here I must have the spelling correct because we are not using TypeScript to double check it. And then here participants, and then dot caller dot socket ID exists. So here I'm performing a check to see if we have the caller socket ID. Okay, let me first go back a bit. Here we have confirmed that it's the receiver who emitted the event, and we want to send that event to the person who called us. For us to send that event, we must have the socket ID for that person, and that is why we are checking if we have the caller socket ID. If we do, then we will send that particular event or that particular SDP data to the person who called us. Okay, so here we check, do we have data dot ongoing call dot participants dot caller dot socket ID. If we do have that, then we will be able to send the event to that person, and we'll say io.to, and right here we will pass that socket ID, and we can just copy this. You could set it to be in a variable if you don't want to repeat yourself so much, but I'll just copy paste there it is, and I'll say dot emit, and here I'll invoke that. We will emit the WebRTC signal, and again the spelling is very important, signal, and right here I'll use a comma, and here we will pass the data we want to emit. And I think we can just say data because this object, yeah, it will be exactly that. So we will emit the data. We don't need to repeat defining the object again. So there is our own WebRTC signal, and we should come down here and we will say export and default, and right here I'll say on WebRTC signal. Now I want us to just complete working with this particular function. So we'll also cover here, in case the caller is the one who emitted the event, then we want to send that event to the receiver. So here we will check if we have the socket ID for the receiver. So we'll just copy paste these right here. They are very, very similar. It's just that here we are sending to the caller, here we will send to the receiver. So if it's the caller who emitted the WebRTC signal, we will send this signal to the receiver. Therefore, we check if we have the socket ID here for the receiver. So receiver, again, the spelling is very important, and I keep messing it up. So make sure yours is fine, because things might fail to work because of the spelling here, and JavaScript does not double check that, but we might get an error maybe when running the application in case of any issue. But now right here we check if we have this socket ID for the receiver, then we emit io.to socket ID here basically, then we emit the data using this WebRTC signal event. Very nice. So now we are done with this function. We need to come back to this server and we need to import this on WebRTC signal. I'll click on that. After clicking, at the end you just hit Control Space to auto import that particular function, just like that. So we have it here. On the client, we need to listen to this particular event. So on socket context, we will listen to WebRTC signal. Okay, here we are emitting, but we are not listening to any of that event. I'll come here to the course, and I think I can add that particular event right here. Here we had socket.on incoming call, and now we will add another one. we'll say socket.on, we invoke, and we will listen to which event? WebRTC signal. And then at the end here, we will call a function and we'll just say here complete peer connection. So this is a function that we will use to complete our peer-to-peer connection. And let's go ahead and create this function. Above our handle join call and after create peer, we will come right here. So I need to do it after create peer so that create peer is already defined when we need to use it in this particular function, because we need to create the peer for the person who called. Const complete peer connection. This will be equal to, we can make use of a use callback hook to optimize this, and it will receive an arrow function here and a dependency array. Very nice. Just to be done with the dependency array, we'll have local stream, then we'll have create peer, then we'll have peer, and we'll have ongoing call. This will be an async function. Then it will be able to receive several stuff. It will receive our connection data, and that data is the one that we emit here. This data, the data is the similar as the one that we have on our handle join call. Don't know if I should show you this data. So as you can see, we will receive an SDP, we will receive ongoing call and is caller. So those are what we will receive in our complete peer connection as connection data there. And these will be of type, I don't think we had a type for this, so we will add an object and we'll say SDP will be in this object and it will be of type signal data. Then we will have ongoing call and it will be of type ongoing call. Then we will be having is caller and this will be a boolean. Very nice. So those are the things that we receive in this function. Note that this is in these brackets. Okay, then at the body inside these curly brackets we will do stuff. Right now we are executing this function on the person who called us, and when making the call we had set up the local stream. So first of all, we check, do we still have the local stream going on? So let's say if we don't have the local stream, we want to return. Okay, so we can console.log here and we say missing the local stream, and we just immediately return there. Now right here, if we have a peer, this is now for the case where we receive an answer from the person who called us. Remember, this function will be used by two people, both the receiver and the caller. What we'll do here is to complete the peer-to-peer connection, and we'll do it like this. We'll just say peer.peer connection. If we have signal, we will go ahead and say connection data.sdp. So we pass the SDP data for the caller. That will complete the peer-to-peer connection. I don't know if that makes sense, but once we complete, we'll go through the flow of the code and hopefully it will make sense. Once we do that, we will immediately return. But if we don't have a peer, what we will do right here is to emit an event similar to this one. Okay, we will need to create a peer like we did here, and we will need to know the participant user. In that case, now the participant user will be the receiver, and then we will emit the event. So I could generally copy this code. I'll copy and I'll come to this part and I'll paste. We'll need to rectify some stuff. For example, the stream. Here we will say local stream. For the participant to user, this will be the receiver. So I'll say connection data, then dot ongoing call dot participant as the receiver there. Then here we emit this WebRTC signal to the server, but now here where we have is caller, we will set that as true. So this is the caller emitting this. Okay, and this will be it up to this point. Maybe I can try to do a quick recap of the flow of what is happening here. So the first thing that we do is to call a user. So we'll have handle call somewhere, handle call. That is the beginning of everything. So handle call, we call and we emit this call event. The server will receive the call event and it will call this on-call function. The on-call function will go ahead and emit an incoming call to the person whom we called using their socket ID. And on incoming call, we will receive that, or we will resend that on the client, the incoming call. So on our use effects down here, so we resend to incoming call and we will have this on incoming call. And when we have on incoming call, I think we'll set up some state. So where is that now function? On incoming call, we just set up the ongoing call, the participant and is ringing property. When this is ringing, we will see the call notification on our UI. And then on the UI, we can either hang up or answer. If we happen to hang up, we just stop everything. We haven't implemented hang up, but we will do later on. But if we happen to answer the call, we will call this function handle join call. And on handle join call, what we will do, we will set up the local stream for the receiver. Remember, the receiver is the one who is answering the call. So we set up the local stream and then we create the peer for the receiver. Once we successfully create the peer for the receiver, we will emit a WebRTC signal. This SDP data is for the receiver. Then we pass the ongoing call and we say that the person who emitted this event is not the caller but the receiver. So once we emit this signal, this will go to the server and this is listening to that signal or that event. And then we call on WebRTC signal function, which we have just created in this particular episode. And this function, we get to this point. At this point, we check, is it the caller who emitted that event? And in this case, it is not the caller. So we will execute else here. And we will check, do we have the socket ID for the caller? If we do, we will emit WebRTC signal to the person who called us. And what we are doing here, we are emitting a WebRTC offer to that person. So that person will resend to this WebRTC signal on our socket context. And now down here, we get the WebRTC signal here. So we resend to it. And then the person who called us will run this function, complete peer connection. And then we will come to that complete peer connection, this function we have created right now, and we'll check if we already have our local stream. If we do, we continue. If we have a peer, in this case, we will not have a peer, okay? Because this peer that we had set up is for the receiver, but here now the caller is the one executing this function. We will not have the peer, so we'll skip this if statement and we'll come here. We will create the peer now for this for the person who called. Once we create the peer, we will set the peer to our state. So peer connection to be this peer, the participant user, and then we will have the stream. The stream will be updated in create peer. Remember, we were listening to some events. You can check the last episode for that. And then the person who called us will emit WebRTC signal again. And in this case, we will specify that the person who emitted this event is the caller, the person who called us in the very first time. Now, again, back to the server, listen to that event on WebRTC. We come back here. Then now here we'll check, is it the caller who emitted the event? And we will see, yes, it's the caller. Now we will not execute else, but we will execute this part of the code. And in this case, we will emit WebRTC signal to the receiver, okay? To the person who emitted the offer, now we emit for them an answer. We come back now to socket context. And now here we listen to WebRTC signal again. WebRTC signal, and we will call complete peer connection again. Now in complete peer connection, let's come here. In complete peer connection, we will check, do we have the local string? We'll see we do have the local string. Do we have peer in state? And here now we will see that we have a peer in state. And when we have a peer in state, we will complete the peer-to-peer connection and we will return. We will not execute this. Now, once this connection is going, that is it. Now the ICE servers will handle the rest. We'll handle the video and audio sharing. Okay, they'll start now talking and so on. But we still have a step that remains where we need to show the other peer on our UI. Right now on the UI, we are just showing the local string. So I'll see you on the next video where we will cover that. If you are enjoying my content, remember to subscribe to support my content, and also share with your friends who also want to learn Next.js, React, and so on. Hello everyone. So in the last episode, we were able to create this function which helped us to complete the peer-to-peer connection. And in this episode, I want us to show the video for our peer on our UI, so that when we make a call, we can see our own video and the video for the other person. And I have already done that, so I'll take you through the changes that I have made, and there are just a few of them. That is why I don't need to type things out. So the first thing that you need to do is to go at the bottom of socket context file, where we had the use effect that was listening to these events, the incoming call and the WebRTC. So in the last episode, we added these, but we didn't add this one right here for cleanup. So what you need to do is to check if you have this line right here. Okay, socket.off WebRTC signal, then we clean up our complete peer connection, and then you will add complete peer connection right here at our dependency array. And then we already had our peer in the state, so the first thing that you do is to add it at the type. So you add here peer of type peer data or null, so add this line, and then at the very bottom you add it at the value right here. You add peer. Now once you do that and then you go to video call, you'll be able to access your peer from use socket, and then you'll also access the ongoing call. So bring in peer and ongoing call from use socket, and then now down here you'll update this right here, is on call. So initially we were setting is on call to a hard-coded value, but now we'll make is on call to be dynamic. So you'll add this line right here. You'll check, do we have local stream, and do we have peer, and do we have ongoing call? So if we have all this, that means that we are on a call, and we'll set is on call to true. Else if any of this is missing, we'll set is on call to false, and you'll add is on call right here. And then finally you'll add this line right here to show the video for the peer. So it's pretty easy. In peer we have a stream, so we check, do we have a peer, and we have peer.stream. If we do, we show our video call container and we set stream to be peer.stream, and is local stream, we'll set that to false. So here we are showing the video for the other person. This is the video, like our own video. And once you do this, you'll be able to see two videos now whenever you make a call, and we can test that. So you will run your application npm run nodemon or npm run dev. You can use Chrome. I recommend Chrome, and one tab will be normal, the other one will be on incognito. Here I logged in with an email and password. Here I have signed in with Google. So I'll call this user and I'll initiate the call like that. Okay, and once we do that, we can already see the local stream here, and then right here we can see the incoming call. Okay, and once I answer, what now will happen? It will emit that WebRTC signal, which will go to the server. The server will send it to this person who called us, and this person that will see that offer, and then when we get the offer, we will now create a peer on this side and emit an answer to this user, and this user will complete the peer-to-peer connection and will be able to see the two videos in both places. Okay, so I'll click answer, and as you can see, now we have two videos. One is at the top here, the other one is at the bottom here. So they are blank because I have hidden my camera, but I can probably show it for a minute. It's just right here. Also, it's not super clear, but as you can see, we have two videos now, and the reason that they are the same is because I'm using the same camera. We need to style this so that it looks much better on both. Okay, I'll just go back to the code, and at video call, what you need to do is to add a class name here, and we will say margin to the top of 4, and then we will say relative. Very nice. We say this is relative so that one of the video, our own video, we will make it to be smaller and to be on top of this one. We go now to this video container, so control click, that will open that component. We had created a cn function when beginning this particular course, I think. So we will make use of that cn function, cn, and we do that, control space to import that cn function. So inside this function, like when we call it, we'll have a comma here, and then we will check, do we have the local stream, is local stream, and do we have is on call. If we have those two, that means that we are on call, and what we will do, we will conditionally render the local stream. So if it's not a local stream, these styles will not be applied. That means that the peer will not be affected by these styles. So here I'll say width to be 200 px, and for like mobile, you could probably change the styles and so on so that it's responsive on mobile. So here in this course, I'm focusing mostly on the logic and not the styles. So h auto, and then here absolute, then border. Here I'll say purple hyphen 500 so that it have a nice border, and then here I'll say border will be of 2, and that is about how many px? 2 px. Nice. So we just do that, and now it will look much better. So I save, and then I come back, and right now I think that should be automatically updated, and there we go. So as you can see now, we have our own local stream right here, and it's a small one, and then we have this big one for peer, and now we have the video going on. And the next thing that we will do now is to end a call. So we will implement a function to hang up, we'll emit the events, and then we will clean up everything whenever we receive the events and whenever we are making that like hang up event. So I'll see you on the next one where we will handle that. So in the last episode, we were able to show the video for the other peer, and as you can see now, we can have a communication going on between the two peers. And in this episode, I want us to focus on end call, where we will hang up the call. So there are two situations where we hang up right here when we end call, and then whenever we receive a call notification, we could answer or hang up. Just jump into socket context, and we had already added this particular function, handle hang up. I have made this update. You will add data, and the data will be of type ongoing call, which is optional. Ongoing call or null is emit hang up, which is an optional boolean. So this data will be received by that arrow function. And now I want us to work on the body of this arrow function. If we have socket and if we have a user and if we have data dot ongoing call and if we have data dot is emit hang up. So if we have all this information, we will go ahead and emit a hang up. So here I'll say socket dot emit, and we will invoke that. The event that we will emit is hang up. Then the data that we will pass on will be here. We'll say ongoing call will be data dot ongoing call, then comma. So we'll pass the ID of the person who is hanging up the call, and we'll say user.id. So that is the object that we pass to this particular hang up event. We will handle that event on our server, but let's continue down here. After this if statement, we will reset everything. So we will set the ongoing call to be null. We will set peer to be null. So that means that on our side, the call will automatically be cleared. And then right here, I'll say if we still have a local stream going on, and we'll say local stream dot get tracks. We will go through each of them. So we'll say dot for each track. Remember, we have video tracks, we have audio tracks. What we will do, we will get a track at a time, and then right here we will return track dot stop, and we invoke that to stop the tracks. Then we will go ahead and reset the local stream as well by saying set local stream to be null. We will set up some state which is call ended. Const is call ended and set is call ended. Then right here we'll say this is use state, and by default that will be false. Now whenever we finish ending up a call, we will call this set is call ended at handle hang up. So look for handle hang up again. After this if statement, now we will say set is call ended. We will set that one to true, and then the dependencies that will make this function to be recreated, the major ones are socket, we have user, we have local stream. We have created this function handle hang up, which will emit a hang up event. When ending a call, we have set is call ended to true, but we don't want it to always remain true. So when we are making a call and when we are joining a call, we will set that back to false. So here I'll say false, and this is on handle call. Look for handle join call. So here we also reset that to back to false so that it's not always true. Okay, nice. We need to add handle hang up to the value right here. So here we will have handle hang up. We add that to the type. Now go to the very top and we'll add that handle hang up, which will receive data, and the data will be of a certain type. Is emit hang up is the other type here, which is an optional boolean. This is part of the arrow function. It will return void, so we add that to the type like that. So now we go to video call, and at the top we will bring in the hang up, handle hang up that is, and we had this end call button, and we had this on click. So now we will complete this on click here. We will return handle hang up. This handle hang up can receive an object. The object will be having ongoing call, and here we will actually go ahead and pass our ongoing call. Ongoing call or null, it's not assignable to ongoing call or undefined. So what we will do, we will say ongoing call is, we check do we have ongoing call. If we do have ongoing call, we will set it now to be ongoing call, else we will set it to be undefined, just to resolve that error. Now this is the first thing that it receives, so comma, and in this case we will actually emit hang up when we click this particular button. So I'll say here is emit hang up is true, and by that whenever we click this end call, that handle hang up will be called. There is another place that we are hanging up where we had our call notification, and we will have a similar function. So what I could do, so I will copy this on click the way it is up to this point, copy, then we go to call notification, and we will receive handle hang up. Then here we will have this button for handle join call, and we have this button which will handle the hang up. I'll say on click. I think I copied the whole of it. Maybe I could paste like that. So I paste it like that, and it will call handle hang up. We will pass ongoing call, and also in this case we will actually emit the event for hang up to the other person. Okay, so far so good. Now let's go ahead and handle the event on our server. We have emitted it on our client, so we go to server.js. We will come right here and we will resend to socket.on. We resend to hang up event. If we receive that, we will go ahead and call on hang up. So we don't have that on hang up, so we'll come to socket events and we'll add it, and I'll say on hang up.js. Hit enter. We come to on call. Let's copy this function. Copy. Come to on hang up. Paste it here. Now here we will remove if statement. Then we will change on call to on hang up. So we are exporting on hang up. We come to server.js. We are calling it here, but we should import it from that particular file. So I auto import it at the top on hang up from that file. Very nice. We are done with this server.js file. I could even like close it. Now we focus on this on hang up.js. We will receive here not participants, but we receive our data there. Remember, the data have the ongoing call and it have the user hanging up ID. So if we come to socket context and you go to where we created hang up function, this is the event that we emitted, hang up, and the data is this one, ongoing call and user hanging up ID. We will say let socket ID to emit to. Then here I'll say if data dot ongoing call dot participants then dot caller dot user ID is the same as data dot user hanging up ID. Okay, so if these are equal, that means that the event that we want to emit, we should emit it to the receiver. So we update this socket ID to emit to right here. Socket ID to emit to will be equal to data dot ongoing call dot participants dot receiver here. So I copy up to that point, and here I'll say dot receiver. Then we will get now the socket ID here, socket ID dot socket ID. Here we'll just go ahead and I'll say else. We will set the socket ID to be that of the caller. Then we'll make use of this socket ID to emit emit an event here. So we'll say if we have that socket ID to emit to, what we'll do here is we'll say io.to socket ID to emit to, and here we'll say dot emit and we'll emit hang up. So on the server we emit hang up to a specific user using their socket ID, and this is how we have determined which socket ID to emit to. If it's the caller who initiated the hang up, then we will emit the event to the receiver. If it's the receiver who initiated the hang up, we emit the event to the caller. Now on our UI, we go back to socket context here. We'll go at the very bottom where we had some events going on, and here are the call events, and here we will listen to that hang up now on our socket context. I'll say socket dot on, and here we will listen to hang up. So I come here and we pass it here, socket dot off. Don't forget to change that. So now when the other person receives this event, they will call handle hang up, but in this case what will happen is that where is that function? In this case, is emit hang up will not have the value of true. So what will happen is that we will not emit an event again. We will just clear our own states. Very, very nice. So I think we could test if it actually works. Let's go to Chrome. We have these two users. Let's call. At this point, this user could immediately decide to hang up the call. So end call. Okay, that should have emitted hang up to this user and cleared the state here, but it didn't. So something is wrong. Hey guys, so I recorded an entire episode solving that error of hang up, and at the end of it all, I realized that I wasn't recording, but I have already written all the code. Now it will be so much work for me to write all the code again. So what I'll do, I'll take you through whatever I did, and yeah, you will be able to catch up. Okay, so what you need to do is at socket context, go at the top here, where we had handle hang up. Here I added this question mark there because it complains that we might not have this ongoing call. So add that check and also add the check here, this question mark there. And that will actually resolve the error and handle hang up will work smoothly. And another thing that you'll do is to restart the server and then you'll test handle hang up. So it will be able to, hang up the call. So right now, if I go right here, mine already works. If I call, we'll have this. And when we click on hang up, it will clear and we'll have this call ended. And that call ended, you see that it's like a notification, it disappears. So I had covered that and I realized that I wasn't recording. So I'll take you through every code. So right now you should be able to at least be able to hang up, but you'll not have that call ended notification. And also this particular end call persists like even after hanging up for your case at the moment. So if I end call, you can see mine is not there, but yours persists. So what you need to do is to go to video call and you'll perform this check. If you don't have local stream and if you don't have peer, you return. If you do that, then this button here, end call, will not show if we are not on a call. And then we have this is call ended. Remember we had like set up that state at the top here is call ended and set is call ended. Now what you need to do is to add it right here at the type iSocket context, and then at the very bottom you will add it at the value. You add at the value is call ended, and then now on video call you'll be able to get that from the context is call ended, and then right here you'll be able to do this. If you have is call ended, you can return a call ended notification right here component, but for my case I'm just focusing on the logic, so I just showed a div with that text. Okay, but as you can see mine disappears after some time, and for your case it will persist. And for you to make it to disappear after some time, you'll go to socket context and at the very bottom you'll add this use effect. You'll define a timeout which will be of type return type of set timeout, and then you'll check if is call ended, you'll set a timeout, and in this timeout you'll set is call ended back to false after 2 seconds or whichever seconds you want. 2000 milliseconds is 2 seconds basically. Then right here you clean up the timeout. So clear timeout, timeout, and here we have these as dependency. So create this use effect, and after doing that, now yours will work exactly like mine. So you'll be able to make this call, and after some time we have the call going, and you can end the call from here. Both call ended, after some time it goes. So up to this point, as you can see, we have the call going. We can be able to end call, answer call, which is really cool. So let's try to call and answer here. So we have this going on, and you either of them can end the call. Everything is good. Awesome. Now the next step or the next video, we will be able to deploy this application, and we'll see how we'll do that. And the thing is, we will not deploy on Vercel because of our custom socket server, which we created at the bottom here. So I'll show you how we will deploy, but if you're able to deploy to Vercel, well and good. And another thing is that you could take this application to the next level. We have come up to the end of this course, by the way. We just need to deploy. And what you could do to take this course to the next level, or this application, is to try and implement group calls. Now, the difference is that, for example, on our server, whenever you are emitting the event, you'll emit to many people. So here, for participants, here we just have one receiver, but now we'll have many receivers. So you'll have many socket IDs to emit to. What you will do is to just loop through the IDs and then emit the event to each of those IDs. We'll have one caller, yes, but many receivers. And anywhere you have one receiver, know that you should be emitting to many receivers. And that is the tip that I give you so that you can try to implement group calls. So I'll see you on the next one. Hello everyone. In this particular video, I'll show you how you can deploy your video call application. And we will be making use of render.com. This is the platform that we will deploy our application because it's free, and also you can easily deploy your Node application here. You can also deploy many other applications in different technologies. So render.com is a very nice place to get started with. The reason that I am not using Vercel is because we created this custom server, which Vercel does not support. I'm not sure if it's possible to deploy to Vercel, so you can try it out. But in this case, render worked well for me. So before we continue, there are a few changes that I would like you to make. The first one, open server.js file, and then here at port, you'll add process.env.port or 3000. Okay, so this 3000 is hard-coded value, but when we deploy, the server that we deploy to will automatically pick a port. So we do this to pick the port. The next change that you can make is in video call. So I realized that the video is not well aligned. So what you can do is to add a maximum width to this div container and then say mx auto. The reason why I'm using 800 is because this 800 is the same as what we used in video container here of 800. So set that width, which is a max width, and then mx auto will automatically center it, and it will look much better that way. Okay, so that is the other change. The next change is I would like us to call this handle hang up. So I could copy this up to this point, I guess. I will copy handle hang up and I'll go to socket context, then look for handle join call. Sometimes you will not get the stream here. For example, if the camera is already in use, if you don't have a camera, so you are not able to, for example, join a call. So what we could do before we return, we could just hang up. And I'll go ahead and save. After that, we need to add this project to GitHub. I had already connected this project to GitHub myself, so I can remove that connection. If you had not added to GitHub before, you don't need to do this. But for my case, I want to start afresh, and so that we can add this to GitHub. So we have this .git folder, which is usually hidden. I'm on Windows 11. I have view, then we have show, then we have here hidden items. You can see it's checked. If I uncheck, this .git is not there. But if we go to show and we click to show the hidden items, we see this .git. So what I'll do, I'll delete this .git folder, and that will remove the previous connection with my GitHub so that I can start afresh. Okay, so I'll go to GitHub just like that. And on my GitHub, what I'll do, I'll create a new repository. So I'll go to repositories and then I'll say new. On new, I can give the repo a name. I'll say vidchat YT for like YouTube, just a name to press hold. I'll make this private. If you want the source code, you can get it on my Patreon. Now here I'll go ahead and create the repository. Now, once we create, we will go to the code. Pop the terminal, Control J, and we'll have this terminal. I can say clear so that we start afresh here. Now here, what I'll say is git init to initialize a git repo. Git init. I'm following these instructions here actually. Git init, and that will create that .git folder which we had deleted, but right now it's not connected to any GitHub repository. We will connect it right now, and you can see we have all the changes here now. And then git add or, and you need to make sure that you are avoiding node modules. Make sure you have .git ignore and you are ignoring node modules, because that folder is usually too big. So here what we'll do, we'll say git add all, and we add all those to the staging area for a commit. Let's go ahead and commit. So I'll say git commit -m, and this could be first commit, but I'll say vid chat. Very nice. I hit enter. So all those were committed, and you can see now we need to publish this branch. So what we need to do is to first create a main branch, and I'll say git branch -m main. I copy that command, I paste it here and hit enter. Then I connect this local repository to this GitHub repository by running this command. So this link is to this particular GitHub repository, which is our remote repo. So git remote add origin, then that URL. So I'll paste here, and that will create that link between this local repository and this remote repository. Then we push our code by using this particular command. So I'll copy that and I'll go ahead and paste. Hit enter, and now our code will be pushed to our GitHub. So we'll wait, and I think it's done. So if I hit a refresh here, we should see our project on GitHub, and there we go. We have all these files for our project 1 minute ago. Now the next thing that you need to do is to go to render.com. In render.com, you will click on get started if you don't have an account, and you'll sign in with I recommend GitHub because we'll be using that. So here I'll go ahead and sign in with my GitHub account. So sign in GitHub. So all you need to do is to go to new, then go to web service, then git provider is where we will get our project, and this is our project here, vidchat YT. Click on that project and you connect. Very easy to deploy actually, very easy, not unless we get issues, but it's easy. So this will remain to be the command for starting the application, but if you had changed the command, you need to change here. But for our case, if I go to our package.json file, let's just check package.json, you'll see npm run start. We'll run this command node server.js if the application is on production. Very nice. So that will not change. Now you'll come here and you will see we have a hobby tire. You click on hobby, and if you want more features, you can use the premium ones. Now you go down here, we need to add environment variables, and we'll say add from .env. So I'll click on this one, then open your project, go to .env.local, copy these environment variables, copy, then jump back to browser and paste them there. And once I paste, you can see we are able to add those environment variables like that. And once we do that, we go ahead and we deploy the web service, and we see if this goes through. So we'll give it some time to complete deployment. Now, as you can see, it's building, and you can go to logs to see if you get any errors. So I am still waiting, but the logs are not showing. So I'll check again. Deploying using node version. Okay, I'm not actually sure if it's deployed or not. Okay, I think it's deployed. Your service is live. Very nice. So now, as you can see, we are live. Now to get your application, it's just to click on this link. So let's click on this link and see if it opens our app. And there we go. Our app is deployed. And guys, if you visit this link right now, you'll see this app is there. And now we only have one user here. So now I logged in right here with an email and password. I make a call. I allow. And we receive this here. I answer. And there we go. So as you can see, we are live and our video call is working. So that is it, guys. I hope you enjoyed the course. If you liked my content, please make sure to support it by subscribing, by liking, and by sharing with your fellow developers and on your social network. So I'll see you on the next one.